Hello, Shagat the Known here. Welcome back to another Rust coding stream where we are continuing the Rust roguelike tutorial. If I can talk, here on the 10th of October 2022, local time 16:29. Just a little recap of where we're at from last time. We basically, I think, let me double check. We got through the map, the field of view generation. That's the big thing. Oh yeah, monsters. That's right. I was like field of view and something else. Monsters. So I was like, wait a minute. I had this in my mind a moment ago and it just slipped. So we have monsters like yelling at us. You can see in the bottom at the console there. And we have a field of view system with a map memory. So notice that the map goes gray in places that we have visited but can no longer see. And yeah, that's about it. So this time we're going to be getting a little bit more in depth in terms of making it more of a proper game. And by that, I mean we're going to be adding combat, dealing damage and taking some, and we're going to be adding the initial user interface. So this is going to be a pretty lengthy one here. If I click back to the, if you look at the scroll bar here, as I click back to the previous section, monsters, you'll notice that monsters is about twice as long of a scroll bar. Ergo, that means this dealing damage section is going to be about twice as long of a section, since the scroll bar is about half the size. So we'll be in for a little bit here, and then after that I'll do the basic user interface, which is a little bit less lengthy. So it'll be one pretty long section here, and then a bit of a shorter, but a bit of a mid-length section. So let's go ahead and get started. Now that we have monsters, we want them to be more interesting than just yelling at you on the console. This chapter will make them chase you and introduce some basic game stats to let you fight your way through the hordes. So chasing the player. First thing we need to do is finish implementing base map for our map class. In particular, we need to support get available exits, which is used by the pathfinding. Okay, I also want to mention something. I like the idea. I haven't actually read through this section or even skimmed it much or anything, but I like the idea of starting it by getting them to chase the player, just get one thing happening, then later on we can actually add damage or something. Instead of trying to do too many things at once, we want to break these apart into individual increments to get the monsters working how we would like them to. So yeah, we need to implement base map, and I guess we're going to have to learn why this get available exits is used. So we'll see what that's all about, but it's apparently going to be used with pathfinding or something. So let me get over here to the map.rs and let's find the base map impl. Here we are. So impl base map for map, and we have is opaque. Now if I do get available exits, we return a vector of tile indices to which one can path from the index. These do not have to be contiguous. If you want to support teleport pads, that's awesome. Default implementation is provided that proves, there's a typo, that proves an empty list in case you aren't using it. Note that you should never return the current tile as an exit. The A-star implementation really doesn't like that. So A-star implementation means that we're using the A-star algorithm, which is a common pathfinding algorithm. It's very widely used in gaming. It's pretty quick and efficient. There are other options, and there are better options for specific behaviors if that's what you're looking for. But A-star is a pretty good starting point for most people, and it would do the job for most people. If you're really trying to go for a life simulator and you want things to seem more natural, you'd probably need something more custom. So I'm still not entirely sure. A vector of tile indices to which one can path from the index. So that's essentially all the open tiles on the map is what I'm guessing. Calling them exits is a little odd. Maybe I don't remember something about A-star, but calling them exits is a bit odd to me. So we're also going to make a helper function as well. So let me go up and make the helper function first. It's in the map impl, which is here. Let's go to the end of the map impl, and we'll add this helper function called isExitValid. and it takes a mutable reference to self. So we call this on the map, and it takes a couple coordinates, well, a coordinate. And if x is less than 1, so that's basically saying if it's the border of the map, and x is greater than self.width minus 1, or y is less than 1, or y is greater than self.height minus 1. So again, that's straight up all just checking the borders. Return false. And we don't have an else clause, so what we say is let index equal self.xy index with those values there. And that actually gets us the path into the map, right? So we say self.tiles, idx is usize, not equal to tile type, wall. So yeah, it's just getting all the I don't know if I said it right earlier, but it's getting us all the floors, all the things that are not walls. So then that just means they can path to anything that's not a wall, that's not on the border, etc. Or that's not outside of the range of the map. All right, so then we go back down here. We're going to use this helper. The other thing, we're going to need to underscore this because it's being used now. Well, it's going to be used. And everything else is okay. I'm curious about this small vec. We're probably, I want to read into that a little bit because it's hard coded as it's a small vec of tuples with usizes and F32s, and it's 10, meaning it only has 10 elements in it, right? So let's see how this works. I'm wondering if it is factoring in a range, or I don't know. We'll find out. So what we're going to do is we're going to get the exit. We're going to store the exits. Let me exits equal RLTK small vec new. And I guess now is a good time to just read what small vec is. And later we're going to return exits. So we'll watch the type resolve itself. And small vec is a vec-like container that can store a small number of elements in line. Small vec acts like a vector, but can store a limited amount of data in line within the small vec struct rather than in a separate allocation. If the data exceeds this limit, the small vec will spill its data into the heap, allowing a new buffer to hold it. Okay, that's actually interesting. The amount of data that a small vec can store inline depends on its backing store. The backing store can be any type that implements the array trait. Usually it's a small fixed size array. For example, small vec U64-8 can hold up to 8 64-bit integers inline. All right, so we'll have to see just how this is being used. Like, so what we're saying, I guess, is yeah, so we can hold 10 of these and then everything else spills over. Okay. So let x equal index as I32 mod self.width. Let y equals index as I32 self.width divided by self.width. Okay. Wait. I don't know how that mod turned into an and, but I'm glad I caught that. Let w equal self.width as usize. And now we're going to do cardinal directions. So for this, what are we going to do here? If self.is exit valid, x minus 1 and y, exits dot push, idx minus 1, 1.0. And now I'm going to copy this 3 times. I'll have to be a little careful with making sure that I get all these correct. But hopefully I do. Minus 1 and plus 1. And then here, plus W, minus W, plus 1, and minus 1. Okay. So those are each of our cardinal directions. And what's a little odd about this is the way we're managing the index, right? So I'm just wondering what happens on the border. Is exit valid? Oh, it doesn't matter. Yeah. Is exit valid? We've already determined that. That's our helper function. So on a border, it's fine. So we go here, we're going left or right with X. Y is where it gets interesting because we have to basically use the entire width to go up or down. So this is an interesting way to handle it. Not sure what to think yet, but go ahead and click back over. It's not going to be much here. So we have the available exits with the small vec, all that fun stuff. And it says providing exits without a distance heuristic will lead to some horrible behavior and a crash on future versions of RLTK. So also implement that for your map. So a heuristic is essentially a like something that lets you evaluate something else. It's like a there's another word I'm looking for, but it's by the means of which you determine how effective something is. So what you would think of like a heuristic in pathfinding would be something like a cost of how long it takes. If I take this route to get somewhere versus a straight line, the straight line is going to be faster. So you have some kind of heuristic that determines what is the better approach, essentially. So we need this get pathing distance. Return the distance you would like to use for pathfinding. Generally, Pythagoras distance implemented in geometry is fine, but you might use Manhattan or any other heuristic that fits your problem. Default implementation returns 1.0, which isn't what you want, but prevents you from having to implement it when not using it. So we have the indexes here already, and it's going to return some float value, which is what we need. We don't need to read that. That's just about floats. So we're going to take these indexes in, and we're going to say let w equals self dot width as usize. We're just going to get the width out of it, and let p1 is a new point. Index 1 mod w. Index 1 divided by w. This is just a way to convert our index. I did the in32 thing. This is a way to convert our indexes into points, basically. And that's another one where I would encourage to draw a picture out, try to understand how we've done this mapping of taking a one-dimensional array or vector and treating it as a 2D. It would help to draw that out to see how these are how this makes sense. So here we are, RLTK distance algorithm. So distance alg, and then we have some options here. Chebyshev, I haven't heard that name in a while. Wow. Diagonal, Manhattan, Pythagoras, Pythagoras squared. Like Pythagoras is literally run Pythagorean theorem. So you got your a squared, your b squared, and you can calculate the hypotenuse c squared, right? That c squared would be Pythagoras, I'm sure. I don't know what diagonal is going to be, though, to be fair. But Pythagoras just gets you the straight line distance, which is super fast. You also hear it called as the crow flies. I've heard that phrase a lot. Manhattan distance is you treat it like you're going over square city blocks. So you got to go over and then up. It's basically the a squared and then the b squared. It's those two legs of the triangle. You're not really squaring them, but it's those two legs of the triangle. And you know, you're treating it like city blocks where you can't just go over the buildings or something. We're gonna use Pythagoras dot distance 2D, 2D distance between points, and then we have P1 and P2. And this returns us a float, which, yeah, just tells us how far away we are from that. So then this get pathing distance, I guess, is our heuristic, where when we're pathfinding, we use that distance to figure out which selection we're going to make. So we just implemented base map for map. It's pretty straightforward. We evaluate each possible exit and add it to the exit's vector if it can be taken. Next, we modify the main loop and monster AI system. So the question I have is how this is actually being called, though. This is something that I think is being handled for us under the hood, right? So if the exit's valid. So getting available exits is just cardinal directions. Yeah, so we're not going over like the entire map or anything. So exits would be valid exits from your current spot. I think I'm gonna have to see how this is being used. I think it's interesting. I'll have to see how it's being used later. Pretty straightforward. We evaluate. Okay, yeah. Next, we'll modify the main loop and monster AI system. Let's take a look back at that. It's been a few days, so we'll see what we got here. So monster AI system. Oh yeah, ours is pretty short right now. We're gonna have to add quite a few things. So it should be a lot of fun. Got some unused stuff here too. So what do we need? It looks like we're gonna need some new things. So impulse system for monster AI. And apparently we're allowing Clippy to do something that I've never seen before. Type complexity. Oh, is this saying? Yeah, okay. It's basically gonna be, you have so many things, you probably don't want to do that. But we're going to be like, no, Clippy, I know better than you. I'm going to not put that for now and just see if it starts complaining. Like, I want to see the error, or not, it's not an error, but I want to see it. So we're going to start with a write expect. It's going to be a map, a being the lifetime. And then we have a read expect on a point, and then a write storage on view shed. So we're going to change that to write storage. And then after that, we have read storage monster, read storage name, and write storage position. Okay, so now we got all kinds of goodies here, and we're going to have to break all these apart. So we're going to start with mute map, and then player position, and then mute view shed, and then monster, and then name, and then mute position. Okay, so there's all our fun data being brought in. I wish the auto formatter would recognize this is too long of a line. It's probably right about the max limit of what a line can be, but it's not being auto formatted because this gray text, like the types here, these are not actually in the line, right? These are added by the IDE. All right, so now we got to loop through all this stuff. There's a lot of these things that we're going to be joining up here. So this is where the what's it called? High bit set's going to come in handy, right? So we use mute view shed and monster and name. I don't think it really matters the order as long as we match the same order on both sides here. And mute position. So we have view shed, monster, name, position. And we need to change this first one to mute view shed, right? Yeah. Okay. So viewshed.visibleTiles.contains the player position. That's all good. Then we're going to log that the dude shouts insults, whoever that is, the monster. And we're going to now do some extra stuff. We're going to do some pathfinding stuff. So we're going to do RLTK. A-star search. Okay, it's the first thing that pops up. That's cool. So yeah, this is, I already mentioned A-star a little bit as the algorithm, but the start and end are specified as index numbers compatible with your base map implementation, and it requires access to your map so as to call distance and exit determinations. So A-star search, and we're going to do these. Okay, yeah, we're going to be pathfinding to the player, right? So it's map.xy index, position X, position Y, map.xy index. It's going to be player position. Where do we get that from? Missing it. Where are we getting that from again? Oh, that's the resource, isn't it? Is it a resource that we're getting from somewhere? Yeah, I think so. Not that one. Yeah, this read expect. I'm pretty sure that's where we're getting player position from. Read point, yeah. Where's it being named though? Oh, it's coming out of there. There it is. There's so many things there that I was missing it. Okay, got distracted for no reason. So player position dot x and player position dot y. And both of these actually need to be I32s. Although apparently they are anyway, but XY index. Oh, it's doing a U size. And we need to give this an nmute map. There we have it. Let's auto format that so it's readable. There we go. I should turn on the auto, or I say auto format. No, I manually formatted it with the keys. I should actually turn on auto format. Because I do it so often, I might as well just turn it on, yeah? So if the path is successful, so this actually returns us something called a navigation path. Let's see. Can I get some info on that? Holds the result of an A-star navigation query. Destination's the index of the target tile. Success is true if it reached the target, false otherwise. Steps is a vector of each step towards the target, including the starting position. There we are. So if the path is successful and path.steps.len is greater than 1, position.x equal path.steps 1 as I32 mod map.width, position.y equal path.steps 1 as I32 map.width, or yeah, map.width. And then we make the view shed dirty. Because remember, the view shed was the thing that basically determines it's their field of view, and we don't want to refresh it every frame, every time we run through the game loop. So we mark it dirty when it needs to be refreshed. And then all we do is every frame we check, does it need to be refreshed? If something stands still, we don't want to recalculate it every time. All right, so we've changed a few things to allow write access. We requested access to the map. We've also added an allow to tell the linter that we really did mean to use quite so much in one type. The meat is the A-star search call. RLTK includes a high-performance A-star implementation, so we're asking it for a path from the monster's position to the player. Then we check that the path succeeded and has more than 2 steps. Step 0 is always the current location. If it does, then we move the monster to that point and set their view shed to be dirty. If you cargo run the project, monsters will now chase the player and stop if they lose line of sight. We're not preventing monsters from standing on each other or you, and we're not having them do anything other than yell at your console. But it's a good start. It wasn't too hard to get chase mechanics in. I feel like there's a little bit of, not assumptions, but there's a little bit of stuff there that probably could use more breakdown. There's no real talk about how A star works or anything. So I think that would be nice. What I do like, though, is that this was written in a generic way, and we can actually see this here. I was going to talk about this before, but it's perfect that we can even see this here, that the algorithm takes in the third parameter is a map. Actually, so start and end are generics. All they have to implement is try into usize. So those are generics. Anything that can do that try into usize is fine. But the one I'm most interested in is the map. I'm interested in that because it's a Dyn base map, right? So that means it's a trait object. So anything that implements base map can be used here. And that's kind of the nice thing about traits is it's our way of doing interesting, dynamic generic stuff where we could say anything that implements this is good. It's like an interface, right? Because we know that by implementing base map, you've agreed to implement certain functions, then A star search can rely on that. It knows that at least your data structure is capable of giving it what it needs, and that's all it cares about, right? And it can just perform the number, it can run the calculations on those numbers that it gets from whatever the base map thing is. Doesn't matter how you did your map, as long as you can conform to that interface, if you will, right? So I like that. That's a good way of taking the pathfinding away from the map and everything by making it that trait, essentially, or by making it rely on that trait. And basically just in order to say that, I'll say it like this, a search algorithm runs on a map, and in order to make that happen, the map has agreed to do certain things. So that's cool. The exit thing I still feel a little odd about. I don't know how get available exits is being used. Right? This is my problem, I guess. Get pathing distance is the heuristic. So that I get that. We get pathing distance, and that tells us how far away something is. And, we use that to figure out which path is the shortest or the best to take, basically. But get available exits. Return a vector of tile indices to which one can path from the end. Oh, from that index. Right. Then now it's making sense. I was missing that key context there. So from the index, that's why we only do cardinal directions. Now, yes, we can have portals and stuff like that was mentioned. You could define whatever you want here, but in our basic implementation, you can only move in the 4 cardinal directions. So there we are. You put in a tile, you can only move up, down, left, and right if there's not a wall or anything. And that's why we do the is exit valid. That threw me off because I was thinking it was trying to basically, I was wondering how it was getting more information. So what's happening is, I think that's being called multiple times under the hood in order to generate that path. I think it'd be fun to go re-implement A star. I haven't done that since graduate AI course. I think it'd be fun to re-implement that algorithm. All right, so blah, blah, blah. We've already read all that. I didn't run it, though. Let's run it real quick. Okay, let me scoot this. I need to make this thing spawn in the center of my screen. Where's the goblin that was yelling at me? Oh, you know what's happening? Well, maybe not, actually. Hold on. Something weird is happening. There we go. They're disappearing. So there is an issue. I'm gonna have to review and make sure I didn't make a typo somewhere. Because they're disappearing, so I think I made maybe a bad sign somewhere. And I don't know where these guys are going. Because they shout, you see them for that first frame, and then they're gone. Yeah, that guy just disappeared. He was like in the wall or something, so there's something weird going on. That's why we test things. Yeah, see that orc down? Okay, this is where they're all going. They're all going right here, I think. Notice how they're not moving out of that wall, but the other ones were moving. I could be wrong. Let me take a look over these and just make sure I didn't make any dumb typo. Oops. Didn't make any dumb typos. And then we'll continue on. This is the big culprit first, is let's just look over monster AI. Path is successful. Double N, path.steps.len is greater than 1. And we get the second thing, path.steps.1. Oh, I did an and. I did that twice today. Why did I do that? I said mod and then I put an and. What is wrong with me? Okay, let me try running it again. Because that may have been all it was. Anding that together is probably not going to get you a good result. That was a bitwise and, so that's actually doing some funky stuff there when we do that. Yep, there we go. Quick, simple, easy fix. I'm glad it was the first place I looked. So this is actually very similar to the pathfinding issues that we had in the previous roguelike tutorial. That right now, they don't have diagonal motion, neither do we. So notice how they get stuck on the hallway. And this guy will never go up the hallway unless I go down here, then he will. And now they're on top of me, and that was part of the problem. Now there's 3 on top of me. I can collect them all. It's like Pokemon. Just running around with a collection of orcs and goblins. So there we are. It's working as intended now. Do not put an ampersand when you mean to put a % sign for mod. Don't ask why it's happening today. So now we're going to block access. We probably want to do that for all like, entity is not the word. Players. Looks like we have a blocked thing on the map that we're adding. I was going to say the player should block things from moving onto it. The monsters should block things from moving onto them. So monsters can't walk on top of each other, etc. So yeah, block and access. We don't want monsters to walk on top of each other, nor do we want them to get stuck in a traffic jam hoping to find the player. We'd rather they are willing to try and flank the player. We'll accompany this by keeping track of what parts of the map are blocked. First, we'll add another vector of bools to our map. We'll also initialize it just like the other vectors. I said bools, like, it sounds right, I guess. A vector of booleans. A vector of bools. Okay. Sorry. So down here at the bottom, pub blocked vec bool. And we have to initialize this. It's probably going to all be false initially. Yes, it is. Blocked vec false 80 by 50. So one issue that we're going to have, by the way, is if I keep trying to maintain both of these, eventually it's going to become a lot more difficult to maintain this other map, I think, because of the amount of things that we have to worry about when initializing and working with it. But it would be fun to maybe test this one again at some point and just see how it works. With some of the new logic in place, monsters and all that. So then we're going to introduce a new function to populate whether or not a tile is blocked. So in the map implementation, impl map, is there a quick way to go to the matching brace? There's got to be. I just don't know what it is, but there's got to be, right? Pub fn populate blocked and mute self. So it's it's mutable because we're actually modifying these values for I and tile. So it's going to be an enumerated iter and self dot tiles dot iter mute dot enumerate. self.blocked I star tile equal tile type. It's not an equal. Tile type wall. So we're just comparing, we're dereferencing tile, which is a tile type there. We're dereferencing that just to do the comparison. And if it's a wall, we make it blocked. Okay. Function is very simple. It sets blocked for a tile to true if it's a wall, false otherwise. We'll expand it when we add more tile types. While we're working with map, let's adjust isExitValid to use this data. So what are we going to do with that? Let's see. Let index equal self xy index, and then instead of this, we're actually checking that. It's going to be not self.blocked index, because we already know if it's blocked now because of that. So this, hang on. This is quite straightforward. It checks that x and y are within the map, returning false if the exit is outside of the map. This type of bounds checking is worth doing. It prevents your program from crashing because you tried to read outside of the valid memory area. It then checks the index of the tiles array for the specified coordinates and returns the inverse of blocked. The exclamation mark is the same as not in most languages, so read it as not blocked at index. Now we'll make a new component, blocks tile. You should know the drill by now, and we're gonna have to register it. So let's go ahead and work on that. I'm gonna just double check, make sure nothing else changed. I didn't think anything else changed, but x less than 1 or x is greater than self width minus 1, y less than 1, y greater than self dot height minus 1, return false. We get the index. Yeah, all that's fine. Okay, so in components, let's add us a new component. And what is this one now? It's going to be derive component debug, and it's a blocks tile. We're going to need that name. I'm going to be lazy. So we just get down here and, you know, it's faster to copy everything else and type blocks tile. I was about to do that to just duplicate the line. And I was like, but I already copied blocks tile. I'll lose it. Yeah, whatever though. So we register it, we do all that fun stuff, and then we're going to apply it to NPCs. So our NPC creation code becomes, where is it at? It's going to be another with component, yeah, right after name. Yep. Dot with blocks tile. And lastly, we need to populate the blocked list. We'll probably extend the system later, so now we'll go with a nice generic name, map indexing system.rs. Okay, there's a lot going on here. So we need a new file, map indexing system.rs. And we're going to use the specs prelude. We're going to use a couple things I'll copy in because I want to be lazy on that. So we're going to get the specs prelude. We're going to use map position and blocks tile. And it's a pub struct map indexing system. That way we can do an impl on it. And it's going to be impl. Can I do impl system for map indexing system? And then will it complain about, it's not complaining about lifetimes, okay. It probably will later. I don't think there's been much of an explanation about the lifetimes. But it would probably complain later if we don't add them. I don't know. Some lifetime, so Rust over time has gotten better about inferring lifetimes and figuring things out. So some older code required explicit lifetimes and does not anymore. So there could be a chance that we wouldn't need to do it here. We're going to get write expect on map. We're going to get read storage position and read storage blocks tile. This is our system data. And then we need our favorite function, run. We pass in that system data. And now what are we going to do? We're going to unpack all that stuff. Map, position, blockers, equal data. Map.populate. Whoops, I'm looking at the wrong thing. Oh no, we're good. Yeah, populate blocked. For position blocks, but we're not using blocks. In position and blockers join. We're gonna get the index, so map.xy index. We're gonna do map.blocked idx equal true. Okay, so populate blocked. I'm interested in that. We're also not auto-completing, so did I make a mistake somewhere? Let's compile. No, not sure why we're not auto-completing map populate blocked. Well, either way, let's go here and let's take a look at it again, just to, I want to just describe what's happening and make sure I'm following too. So populate blocked is what we just described, and it literally, and this is why, because I want to see. Okay, no, we do, yeah. I'm a little interested in this. We're going to see how the system gets used, because we're going to populate whether things are blocked or not, and we might be recalculating that a decent amount. And this tutorial seems to care about performance, so I think they're going to do something to make sure that it's not an issue. But I think about that, like every time we run this indexing system, we have to do that entire population. And then also look at everything that has position and information on whether or not it blocks. So a lot to do every single time you index. But basically it's telling the map to set up blocking from the terrain, and then iterates all entities with the blocks tile component, applies them to the blocked list. We need to register it with run systems and main. Run systems. So where are we going to do that? We're going to do it after the monster stuff. So let mute map index will map indexing system. Now we didn't pull that in, so we'll have to do that in a moment. Map index.run now and self.ecs. So we'll come up here. Can it figure this one out? Nope. Mod map indexing system, use map indexing system star. And if we cargo run, monsters no longer end up on top of each other, but they do end up on top of the player, which I already knew was going to be an issue. So I was going to say we're going to have to add something to like all kinds of stuff to make sure that everything that should block does block. Yep. So I want to see two monsters that are not. Oh, somehow lost it. Oh, wait. Yeah. No, they can't because. Yeah. I'm done this. I shoved the orc out. Come on, dude. So goofy. Alrighty. Well, they're clearly not staying on the player because there's another one in there. So it makes sense. So yeah, we need to also fix that from the dudes being on top of the player. So in order to do that, we're gonna make the monster. We're gonna do a couple things. We're gonna make the monster only yell when it's adjacent to the player. I don't know why that's mentioned here. So literally, it's. I'm gonna get the browser up. If you cargo run now, monsters no longer end up on top of each other, but they do end up on top of the player. We should fix that. We can make the monster only yell when it's adjacent to the player. Like, I get that, but that seems unrelated to me. So where's that at, Monster AI system? Tired of that being yellow. There's where it shouts, so we're gonna have to do a check for that, basically. Add this above the visibility test. I'll copy that, or just cut that line. Let distance equal RLTK, distance, alg, Pythagoras, distance 2D. We got to make these points and stuff, so it's going to be point new position X, position Y, 2 star player position, which is already a point, right? Then if distance less than 1.5, attack goes here. Now we're returning. There's something going on here. It says above the visibility test. So to me, this would be the visibility test, right? The distance is close enough, then we do that. I'd like to double check something on the code, on the final. Just want to make sure that's kind of what they're going for. Well, I want to think about it for a moment first, though. Why would we return? So if the view shed contains the player, then we do pathfinding stuff. I guess. In this case, what we're actually saying is if they're close enough, they're not going to move, so they'll attack, right? So yeah, that I guess makes sense. The return threw me off. But I guess we don't need to check the view shed again if they're close enough to attack. I'm going to go into the browser real quick and check this code. Yeah, so they actually have if the distance, else if the view shed stuff. So they actually do it like that. It's right inside the 4. Yep. Okay. Just want to make sure. I want to make sure I wasn't misunderstanding. Yeah, I think I talked myself into why it makes sense too. So it's all good. And then, oh, I need to go. I was like, wait a minute. I don't know where I'm at now. So let me find my spot again. Okay, yeah, we added that, and then we want to stop the player from walking over monsters. So in player.rs, we replace the if statement that. One moment though. I don't see anywhere we're adding the component to the player. I assume that we're going to add that component to the player for blocking, but I'm not seeing it anywhere yet. Okay, I'll put it to the side for now. So we've added that piece of code. And then lastly, we want to stop the player from walking over monsters. So in player.rs, we replace the if statement that looks for walls. This one here. Okay. And it's going to be the block. Yeah, if not map.blocked destination index. That's actually cleaner now because anything can block it. It's not just tiles, right? It's not just a wall type. So that's good. That works. There is something nice about doing that to determine whether it's blocked. Have the map deciding whether it's blocked or not. That may not make sense in maybe a 3D game, I don't know, but maybe for some things, but I don't know if a 3D game should have the map determine. I mean, that's architecture decisions. I'd have to do some more research. I don't know if you'd expect a 3D game's map to be deciding what the player can and can't do so much. I don't know if that makes sense. It is what it is. And since we already put walls into the blocked list, this should take care of the issue for now. So cargo run shows that monsters now block the player. They block them perfectly. So a monster that wants to be in your way is an unstoppable obstacle. But I think they're still going to walk into the player. No? Oh, okay. Why not? Oh, I know why. Because of the code we did in the monster AI system. So tile type is no longer needed here. The code in here does not allow the monster to move anymore. So that's an interesting way. I don't know if the player maybe should have the blocked component. I don't know. It's a good question. Okay, back to the browser. Once I move it onto my correct monitor, though. All right, so yeah, he blocks. It does what it's supposed to. He doesn't walk into me anymore. So there we are. Now, finally, my favorite, diagonal movement. It'd be nice to be able to bypass the monsters, and diagonal movement is a mainstay of roguelikes. So let's go ahead and support it. In map.rs, get available exits function, we add them. So this is going to allow monsters and stuff to do that. And then we're also going to allow for players. So we have to do this in 2 different places. I wouldn't say that's a big deal in this case. Sometimes you can't really avoid duplicating code. So we're going to say those 4 are diagonals. And I can never mentally do this. So x minus 1, x plus 1, x minus 1. Like, I mean, it's not hard to figure out, but I don't want to do it. These are both minus. Okay, and then over here. Okay, these are funky. And x minus w. There we are. And these bottom 2 are plus, these top 2 are minus. And then this is 1.45. I hope the 1.45 is explained. It's a distance, right? So this, yeah, the F-32 is the distance. So when moving diagonally, it's now a distance of 1.45. In the player.rs input code, we are left, right, up, and down. We're going to add 4 more for cardinals. I'm just going to be really lazy and do this. Or diagonals, I mean. And here it's going to be numpad 9. Whatever this numpad is, whatever this numpad is, and whatever this numpad is. And this only works on the numpad, so we don't have to worry about any other keys. So numpad 9, 7, 3, and 1. And then for the movements, it's going to be 1, -1. -1, -1. It's going to be 1, 1. Probably -1, 1. Yeah, -1, 1. Yo. Alrighty. That should be good, and I can now diagonally dodge around monsters, and they can also do diagonal stuff. Let's see. Yep. Works as expected. I could still be trapped in a corridor, however, but I can get around him. He's getting stuck on the... Okay. I could still use a little help pathfinding. Just like running away. Uh-oh. Trying to trap me, aren't they? Alrighty. Well, that's good enough for me. We got that in place now, so let's get back to the text. So now we're going to give monsters and the player some combat stats, because there's no combat yet. So you probably guessed by now that the way to add stats to entities is with another component. In components.rs, we add combat stats, and here's a simple definition. Guess what? We're going to have to register it and do all that fun stuff. We'll go to components, and we'll add a new one here. Derive component, debug. It's going to be a pub struct. Combat stats. Pub max HP. Pub HP. I32 pub defense. I32 pub power. I32. And let's go ahead and register it. I'm not going to do the same thing I did last time. I almost did. Combat stats. Alrighty. And then we're going to get the player, and we're going to do these for some monsters. Okay. So first, the player... we're on the monsters first, so we'll just do it here. So the monsters are with combat stats. And what do they have? Power is going to be 4. Defense is 1. Health is 16 across the board. Oops, I put 4 twice. I said 1 and I put 4. Okay. I'm going to copy this line so I can just modify it for the player. Here we're going to do that. Player is going to have 30, 30. 2 and 5. So they are slightly stronger. Not much. Alright, that's simple enough, right? Indexing what is where. When traveling the map as a player or a monster, it's really handy to know what is in a tile. You can combine it with the visibility system to make intelligent choices with what can be seen. You can use it to see if you're trying to walk into an enemy's space and attack them, and so on. One way to do it would be to iterate the position components and see if we hit anything. For low numbers of entities, that would be plenty fast. We'll take a different approach and make the map indexing system help us. We'll start by adding a field to the map. Another field. Our map's getting beefy, but that's not necessarily a bad thing. We can be smart about how we use it. So we're going to add tile content, and we're going to add this line here. Initialize it, and there's one more function. Okay. So our map, what do we have? pub tile content vec entity. Okay, we're mad right here, so it's tile content vec new 80 by 50. Here and make this one happy because I'm insisting on maintaining that. Alrighty, now, oh, we need the function as well. So we'll go to the end of the impl block. Say pub function clear content index and mute self. Content in it self dot, I don't know why I said iter already. Tile content iter mute content dot clear. So this is very simple. We're clearing each vector. That's all we're doing. We're just looping through every vector and clearing it. See why we need that. So this is quite simple. It iterates, visits every vector in the tile content list. Mutably, the iter mute obtains a mutable iterator, right? It then tells each vector to clear itself, remove all content. It doesn't actually guarantee that it will free up the memory. Vectors can keep empty sections ready for more data. This is actually a good thing because acquiring new memory is one of the slowest things a program can do, so it helps keep things running fast. Then we'll upgrade the indexing system to index all entities by tile. So this is where it's going to be a little beefier. Let's take a look at it. Indexing system. Oh yeah, we barely have anything in here now, so we're going to have to deduce what's different here. So first of all, write expect map, read storage position, read storage blocks tile, entities, just to get access to those. Okay, we've done that once before. Oops. Oh, that's what's... Oh, yeah, it's just a lifetime. I was basically trying to do the same thing as this, and it was throwing me off. So now we do mute map, position, blockers, and entities. And the only thing mutable is the map. Good. We populate blocked, and then we clear content index. And then for entity and position in entities position dot join. What are we going to do here? Let index, so we're going to get that position, and that's our index. We convert it to an XY index. If they block, update the blocking list. Let p option and blocks tile for blockers dot get entity. If let sum p equal p map dot blocked dx equal true. And then we'll say push. Yeah, I'm not typing that one. That's a long one. So we're going to say push the entity to the appropriate index slot. It's a copy type, so we don't need to clone it. We want to avoid moving it out of the ECS. All right, so map dot tile content index dot push entity. So now we still have our map.blocked code here, but we also have the content being pushed in there. So let's just, I want to break down what's happening, because, you know, sometimes just to make it clear why I do this, it's for me as well, because I'm just writing this code, and now I need to understand what the code does as well. So we populate everything that blocks. We clear the content. We use the if let sum thing. What is Oh, right. You can get an entity. This is a specs thing. So then if the entity blocks basically at this position, if the entity at this position blocks, we set that index in the blocked vector to show that it's blocked. And then we push the entity into the index slot for the tile content. And then we're going to be able to use that, right? We're going to be able to use that for like fighting and stuff. That's why we're doing this. Okay, I just had to get my bearings again. So the way they said it was, we could iterate the position components and see if we're attacking something or whatever. But what we're going to do is we're storing all the entities, and we can quickly just check that index and say, hey, is there a thing here? Am I hitting something? What's going on? So it saves it saves the searching, rather. So yeah, that's that. Cool. Making sure there was nothing else I was missing. So letting the player hit things. Most roguelike characters spend a lot of time hitting things, so let's implement that. Bump to attack, walking into the target, is the canonical way to do this. We want to expand try move player in player.rs to check if a tile we're trying to enter contains a target. We'll add a reader for combat stats to the list of data stores and put it in a quick enemy detector. Okay. I also want to double check one thing. All we care about right now is entity and position. And those are the entities that are being pushed in here. I wonder if... Yeah, I wonder if we're going to end up... like, what if we add scrolls and stuff, right? And we don't want those to block. Or not block, we don't want to attack those, right? We want to be able to move on to a tile. So there's going to be some way we have to differentiate what it is that we're finding here in this tile content. So tile content, yeah, no, I get it. I'm being stupid. So what we do is we just check what's in that vector, and there may be 10 scrolls and one enemy. If there's an enemy, we attack it. So we still have to iterate tile content, but it's a quick way to just see everything in a tile. Right. Okay. That doesn't actually affect how we move. That's what I was making sure. So we'll add a reader for combat stats in player.rs, right? So try move player. What combat stats equal ECS.read storage. Combat stats. We have to bring that in, which is here. Yep. Okay. It's unused because we haven't used it. So let's see. We got our map. Now I got to make sure we're using this correctly. So we have player, position, and view shed. All good. Let destination index. That's all good. Now we want to do some extra stuff here. So for potential target in map.xy index, wait, not xy index, excuse me. I was looking at the line above. In map.tile contents, destination index dot iter. So this is what I just described, that we're going to have to iterate through all the things in the tile to find out what they are. Let target equal combat stats dot get star potential target. So this is now our entity, right? Potential target, yeah, is an entity because that's what our vector is here. And then we're dereferencing that here. We're trying to get an entity, and so it's optional. So there may not be an entity there. Okay. Or there may not be a combat stats there. That's what's most critical. All we care about really is the combat stats. Everything else is going to kind of fall into place. Match target. And all right, you want to do it that way? Fine. You put none first. I always like doing none last. And so we're going to do some t. Now remember, t is a variable name in that case. That's not something that is, you know, it's not supposed to, it's not required to be t. That's what we're naming it. I could call it tacos. I could call it anything I want. Tech. So basically, by doing the match statement, we're destructuring this optional. We're saying if there's something, let's call it t, then let's do some stuff with t. Console log format from hell's heart I stab thee. Oh my, the flavor text is real. Return. So we don't move after attacking. There we are. Failed to resolve that. Why? It's an RLTK thing, yeah. And then T is currently unused, but we're going to be using it in a moment, so I'm not going to bother with it. So if we cargo run it, we'll see that we can walk up to a mob and try to move on to it. And then we'll see that appearing in the console. So look down at the bottom. You should be able to see it pop up. There we are. Hell's heart I stab thee. And there we go. Player attacking and killing things. We're going to do this in an ECS way, so there's a bit of boilerplate. In component.rs, we add a component indicating an intent to attack. So this is actually interesting. You want to melee a component that says you suffer damage. This is interesting. All right. This is not how I expected it to go. Looks like we're adding 2. Yeah, I'll read this first. We want to also track incoming damage. It's possible that you'll suffer damage from more than one source in a turn, and Specs doesn't like it at all when you try and have more than one component of the same type on an entity. There are 2 possible approaches here. Make the damage an entity itself and track the victim, or make damage a vector. The latter seems the easier approach, so we'll make a suffer damage component to track the damage, and attach/implement a method to make using it easy. Very interesting, okay. So, does it have to be a vector? Could it be an accumulator? Because you're going to be mutating the vector. You're going to be pushing into that amount vector a bunch of times. So you're allowed to mutate it more than once. Would it also just be an accumulator? Which would just be, instead of vec I32, just I32 and do like plus equal and just keep accumulating a value. I don't know. We'll see, right? We shall see. Scoot this over and let's get to work on this. You know we're going to have to register these components too. The reason I read through that is because I saw we're going to make multiple components. So I wanted to just be ready for that. And do them both at once rather than click back over. Oh, we actually have a few things on this one. Convert save load is a new one. So once to melee, pub target entity. I don't know what convert save load is. We'll check it out soon. And suffer damage. Pub amount, back I32. Convert, save, load. Let's import that. Where's that coming from? No, it's here. It's finding it. It's the cannot find derived macro serialize. Do we have Saturday? We don't have Saturday, no. I'm not seeing any indication of that. Let me just check the source real quick and see what I'm missing on that. I don't want that thing to be complaining. All right, so we have source, components, specs derive. Oh, we just have, no, we have that. Very interesting. I'm looking at the code here. In the, like, here's the finished code for this section. There is no convert, save, load. It's just component debug and clone for once to melee. We're gonna get rid of that one, even though it is on the in the book thing there. We're gonna get rid of that one. Alrighty, so that's better now. Let's register a couple components. What are these? Once to melee and suffer damage. Now we gotta go back to components and we're gonna do a little impl block real quick. Impl suffer damage. Pub function new damage. Store and mute write storage suffer damage. Victim entity amount I32. If there's anything else. Nope, that's it. No return. If let some suffering we'll store.get mute. We're probably going to get the entity up. Get the victim suffering dot amount dot push amount. Else let damage equals suffer damage amount back store.insert victim damage.expect. So we will crash if this fails, which is maybe not ideal, but probably something really wrong if we can't insert. So we get a write storage on suffer damage, and if there is a suffer damage component, then we push the amount in there. If there's not a component, then we actually use store.insert to add that new component, which is what we've made here. We've made a suffer damage component with a vector with that amount in it. Okay. So we modify the player's movement command to create a component indicating the intention to attack, attacking a wants to melee to the attacker, attaching a wants to melee to the attacker. Alrighty, so player's movement. So in player.rs, where am I at? Or entity, just give me a moment. Destination index. So this is that loop. loop's looking a little bit different. That's what I'm trying to clarify. It's going to be like this. Let entities equal ECS dot entities. Let mute wants to melee. ECS dot write storage. Wants to melee. Okay. So now we're going to be able to link up all the stuff together, right? So for entity, player, position, and view shed. So now we're going to need to get entities. Okay, everything there seems good, I think. And we have a new check coming in before destination index. If position dot x plus delta x. Where's the Give me one moment. Where's the delta coming in? Oh, it's the function. Okay. Oh my god, this is getting beefy. Position y plus delta y less than 1. A lot of stuff there. I want to read that and just double check it all. If position x plus delta x less than 1, or position x plus delta x greater than map.width minus 1, position y plus delta y less than 1, position y plus delta y greater map.height minus 1, return. Okay, we're checking the boundaries of the map again. That's all it is, right? But it's just a lot to read, and you want to make sure you get your signs, your pluses, and your graders and lessers and minuses and everything. You want to make sure that's all accurate. Okay, so if all that's the case, we return. Now we get the destination index, which is all good. Now we have the potential target in map.tile.content.iter. Yep. Let target equal combat stats.get potential target. If let, we're not doing a match anymore, so I'm just going to kill that. If let sum target equal target. Why is it mad? Wants to melee dot insert entity wants to melee target potential target. And what are we expecting? Add target failed. Expected identifier. Oh yeah, we're not doing the match on the target anymore. So I actually need to kill some of this. Question. You could say it's a readability thing, but could you not also do this here? If let sum target equal this. Yeah, you totally could. Honestly, I think that's almost better. Maybe, I mean, it depends on if we're going to do anything else, but I almost like that more. It's kind of like an unneeded variable assignment here, and it probably gets optimized away. But, yeah, just a thought. Just a thought. So, yeah, if there is a target there, then we want to melee that entity Or no, we want the current entity to have a once to melee component for this target. Okay. Got it. And we'll need a melee combat system to handle melee. This uses the new damage system we created to ensure that multiple sources of damage may be applied in one turn. What new damage? Oh, that's not a system though. I was thinking like impulse system, right? We didn't do impulse system for that, but we are going to do it for this melee combat system. So make a new file. And add a couple uses up here. I'm too lazy to type. So we need suffer damage, name, wants to melee combat stats, specs prelude, obstruct, melee combat system, impul. You know what? I'm gonna leave it. We're gonna impulse system, and I'm just gonna try it without. Entities, write, storage, wants to melee. We're gonna try it without the lifetimes and see what happens. Read, storage, name, read, storage, combat stats, and write storage, suffer damage. So one problem I do have with this is basically it's really hard to know why these it's a problem with any tutorial, and it's the reason that I like to spend some time to break down the code that I type after I'm done typing it, because right now I don't know why we need all of this. Like, I'm thinking about melee, and like, we need to know something wants to melee, they need to be able to suffer damage, we need the combat stats, that makes sense. We probably need the name because we're going to say like so and so gets attacked for this much, or we're going to put some info like that. We probably need entities. But what you have to be able to do is, if you're writing this yourself, you have to think ahead a little bit and like kind of do a little mini architect of what this function needs. What does it need to be able to do all this stuff? And you can keep modifying and adding things to system data as you come across. Ooh, I probably want that as well. But I'm just saying right now, it's like, oh, you've got a piece of code here and it just tells you what you need. Always try, think about why these things are being typed. For me, when I'm just typing this code out, it's hard for me to, talk about it, type out what I'm reading. Like, I'm already doing a couple things at once, and it's hard for me to then also think about what's going to be happening in the future. But if you're like listening, if you're watching, it might be a little easier to think about why are these things that are being typed. Just food for thought, right? So we're going to get the entities once melee, or not once to melee, they're naming. Names, combat stats, mute, inflict, damage, equal data. And then we're going to say for entity, once melee, name, stats. In entities, once melee, names, and combat stats dot join. Now, if stats dot HP is greater than 0, if they have health, let target stats equal, where are we at? Combat stats dot get once melee dot target unwrap. Unwrap is a little sketchy, but once melee target, remember, is the thing that it wants to attack. Also, this is what I made a mistake on. I was like, yeah, something's wrong. Something is still wrong, though. Did I get a compile error? I did not. We're not getting some autocomplete here, though. We get that a few times here and there. Like, we're getting it here in this other file, but we're not getting it here for some reason. And it just makes me think I made a typo somewhere. What's going on, Tusk? Just for a quick sanity check, I'm going to copy everything I've typed and just paste over it real quick. We're going to go through target stats, just this part right here. Okay, yeah, we're still not getting the full autocomplete right now. That's okay. We'll deal with it. I cannot read what you said. It's all censored on the chat. Language, dude. Target stats. If target stats.hp greater than 0. So what we're saying is if the current entity has health, then we can do stuff. So if target stat, if the target has health, basically, let target name equal names.get once melee dot target dot unwrap, let damage I32 max 0 stats dot power minus target stats defense. Now this is not what I thought of when it says I32 max. Max size, maybe? We're not getting the autocomplete that I want. But this is the max of 0 or this other value. So what it's saying, if you got a negative, don't apply the negative, right? I didn't know you could do that on I32. I thought there's other like STD compare max and min. That's what I'm used to. If damage equal 0. I'll see what you said in a moment, Tusk, once I get back to OBS. It's also hard to read on my phone. Name and target name. So if the damage is 0, blank is unable to hurt blank. We get the two names. Else, console log. You know what, let me be lazy about it. Blank hits blank for blank HP. And then we have name, target name, and then a big beefy boy here. Suffer damage, new damage, and mute inflict damage. Once melee dot target. And then damage. One, two, three, four. Down. Once melee. Dot. Clear. That's a lot. That is pretty beefy. I kind of want to break down what's going on here. So I don't think it's terribly complex, but it's a lot to look at, and the suffer damage part's a little obtuse right now. So let's make sure we understand what's going on. So the system, we get the entities, we get things that want melee, things that have names, combat stats, and inflict damage is actually suffer damage. So We don't use that initially. We use it down below. Okay. And that's because it's write storage. Okay, that makes sense. So what we do is, although one question. Console log. Name hits blank. Name hits name. Oh, wait. Oops. Name hits target name for, and then we're actually printing this with the debug here. It's going to look a little wonky, I guess. Or no, not a debug. Suffer damage. Let me go take another look at suffer damage. Do derive debug. Now I'm getting caught up on this. Oh, crap, that's why. That's not right. The lines are a little hard to read. I was like, yeah, what is this? That's better for the format. Then we do all this. That's better. Yeah, that's where the writing and stuff is happening. I was like, that doesn't make sense. And I'm surprised something is about this file. Like when I create these files initially, for some reason, they don't seem to be linting right away, which I've never really had much of an issue with, but they don't seem to be linting properly. So I'm not getting like errors or whatever. I mean, I assume I would have had an error if I just, let's try this real quick. Let's cut that and put that back in there. Oh my God. Cargo build. It's not complaining. Got a warning, but actually we could do that. That's got to make it mad, right? Yeah, no, there's something. I guess it's like the file's not being utilized yet. I don't know. That bugs me though. We'll have to register that. Maybe that's all it is. Maybe I just have to register it in the system thing. So, our melee combat system. We'll have to work with it in a couple minutes here. Yeah, we're gonna have to make another system. All right, let me break this down. I'm getting into the weeds a little bit. So, what we do is for entities who want to melee attack, who have a name and have stats, if they have health, they can attack, presumably. So then we say, we then get the target stats, whatever it is they want to attack from once melee.target, we get their combat stats. And if they have health, presumably we don't want to do it on something that's dead, right? So if they have health, then we get the target name. We already have our current name, so that's fine. Like our the attacker's name. And then here we say, let the damage equal this here. So it's either 0 or power minus your power minus the target's defense. Again, if this goes negative, then this I-32 max will give you 0. And then if the damage is 0, you're unable to hurt, we log that and nothing happens. Otherwise, we do this suffer damage and add this damage value to the target. So let's go back one more time to new damage. And the first thing here is actually the suffer damage component for the entity, basically, right? Yeah. Okay. I think that all makes sense to me. I hope it makes sense to you, because there's a lot kind of going on and very little code, actually. There's a lot happening, though, because of the way the systems and components are interacting, which is pretty cool, but it takes some time to wrap your head around it. So then we also need a damage system to apply the damage. We're separating it out because damage could come from any number of sources. So we use an iterator to sum the damage, ensuring that it is all applied. So in order to do this, I guess I'm going to make a damage system file. New file. Damage system.rs and pub struct damage system simple. Oh, you know what? No one got mad about the lifetimes yet, but I'm not using it either. So we'll see. So type system data equals write storage combat stats and write storage suffer damage. Then we have a run self and data self system data. Let mute stats, mute damage, data, or mute stats, damage in. Now I'm curious about one thing. Why is damage being made mutable here, but not here or here? Why is it a write storage if we're not mutating it at all? Curious. Stats.hp minus equal damage dot amount dot iter dot sum I32. That's it. Damage dot, oh, that's why, because we're clearing it down here, so it doesn't need to be mutable in this loop, but it does need to be mutable. Okay, see, my question was answered. That's good. Those are things you should be asking, right? When you're writing the code, you see something that throws you off, you should probably stop and actually think about it and try to understand what's happening. So yeah, this one's pretty simple. We just get the stats and damage and sum up the damage vector. Again, I wonder why we need a vector and why we couldn't just treat a single value, a single variable, an I32, as an accumulator, and then instead of doing damage.clear, it would just be damage equals 0 at the end of this. I would be tempted to swap everything out. It'd also be a bit of a pain to do right now. I might do it between streams or something and just see if there's some critical behavior that we would be missing at that point. So we'll also add a method to clean up dead entities. Where does that go? Delete the dead. Where the hell does that go? It doesn't even say. All right, fine. I'm just gonna check in the source thing. Does it go in the system? Does it go in here? Let's see. Lost track of it. It's called from our tick command after the system's run. Damage system, delete the dead. It is part of damage system. Okay, so that's all I need. I don't need to check the code then. So pub function delete, whoops, delete the dead. and mute world. Okay, let mute dead. Vec entity vec new. Using a scope. Okay, this is interesting. To make the borrow checker happy. So one thing to note in programming, I'll just talk about this for a moment. Unnecessary visibility. Why? Why is it mad about that? Like, unnecessary shouldn't make it that angry. Fine, we'll just do that for now. We'll fix it later. Because it does need to be public to call elsewhere, to call from elsewhere. But it's mad right now, so I don't want it to be mad. This is interesting though, because in a lot of languages, C-like languages, you can make a scope anywhere. So you could do something, you could say let I equal 12. And then you could say let I equal 37. Print line. Let's do it like this. I think that works. Print line I. And then we can come out here and print the I as well, right? Just because that syntax is weird, I'm actually going to change it. I think that's valid though. I think you put variable names in there. I just don't do it very often, but we'll do it this way. So what you're going to get here is you're going to print 37 and then you're going to print 12. And that's perfectly fine because the variable I in this scope is created and dropped and lost and everything once this scope, like all within the scope. So once we go out of the scope right here, we're now referring back to the previous I up above, this let I equal 12. So when it says using a scope to make the borrow checker happy, there's going to be basically, you usually are taking advantage of like force dropping something. That way you can do like an extra thing involving it somehow, right? So we'll see how it's used here. Let combat stats equal ECS read storage combat stats. Let entities equal ECS.entities. And then for entity stats in entities and combat stats. Join stats dot health is less than 1 dead dot push entity. Now after the scope for victim in dead ECS.delete the dead. No, not delete the dead. That's the name of our function here. Delete entity. Victim. Expect unable to delete. Alrighty, so let's see if I can figure out why we needed that scope. We get combat stats and entities. We're using ECS to read a bunch right there. We have a dead vector. We're pushing things into the vector. Okay, stats.hp. You know why I think it is because we're reading, yeah. I think what it is that we're reading from the ECS with read storage and entities there. We're getting things from it, and then we're deleting an entity. So what could happen is we could be invalidating the reference that we're getting from this code here. What if we delete one of those entities, then we've basically invalidated that. So if I do this, it's not mad because something is just kind of broken right now. We'll come back and check it out in a minute because we're pretty much done. So this is called from our tick command after the system's run. So damage system, delete the dead. We never finished, we never actually used this anywhere yet, did we? We never used the melee combat system either. We're gonna need to call both of those. I didn't see it telling me to run it. Take a look at it though. Take a look at one more thing. We'll go to main here and we'll find the systems. So we have map index. So we have visibility, AI, map index. Let mute melee equal melee combat system. We need to bring that in here. Use melee. Oh no, not that. Mod. I was like, why is it not even finding that? Use melee. Star that. Now we're mad. Okay. See, now we're getting stuff. Mod damage system. Use damage system. Alrighty. So now we're getting somewhere. Alright. Why are you mad? You need console. That's easy to fix. And we need the lifetimes. Can I get it to just do that for me? That's not what I want. We need it on system data. Sorry, I'm looking for... We don't need it on system data, but we need it on all these other things. We need it right there, there, and then every one of these needs it. Oh, whoops, it's actually the first thing, and that's not the syntax. Copy that. I wanted to see if it was going to be able to work or not, because so what I need to start doing is just putting those in main right away so we can get proper, like, completion and stuff. Because that's definitely not great. Now we need bop and a bop. That's happy. No field HP on... It's because I made a typo. See, it wasn't even telling me about the typo there. It really doesn't do anything until it's being used. That's bizarre to me. Delete the dead. He's not a member. Oh, I'm in a system impl block, not a regular impl block. I was wondering why I was so mad about that. So then if we do this and this, we can't borrow ECS as mutable because it's also borrowed as immutable. And it points us up to the top there. It points us back up to that. So what we've done is, by doing this, all the immutable borrows get dropped when the scope closes. That's what I was trying to point out earlier. So that's a cheeky way to do things. It's not wrong. It's not bad. Basically, there is a drop that gets called on it. STD mem drop that gets called once it goes out of scope. This function's not magic. It's literally defined as this. It's an empty function that takes ownership of something, and that's basically a way that you no longer have it now. You're no longer borrowing it. Okay. So that's cool. There's one more thing I needed to do now. In main with the systems. So we have the melee combat system. This melee dot run now, and then it's going to be self.ecs. Couldn't remember. All right, and then what else do we need? Damage. Let mute damage equal damage system. Damage.run now. There's a bit of a... Oh, no, there's something interesting happening. I think. Maybe not. No, we're good. All right. Let me scroll back up in the browser here and get this last thing added. So we made delete the dead. We're adding these. And this is called from our tick command after the systems run. Where are the systems running? Right here. So run systems. We just say damage system. Delete the dead and mute self.ecs. Now, do you know why it's not completing yet? Because it can't find delete the dead. And it's something I called out earlier. I was doing it to make it happy at the time, but we actually need this here. That should be. Did I do something wrong? Not found in damage system. Damage system, delete the dead. What am I missing? Generate delete the dead function. Damage system is pub already. Right? Yeah. Okay, so now I'm actually a little thrown off. Let me take a look at like map or something real quick. Pub, map, impl pub function. Or is it this? It's not an impl. Is that what's going on? It's just a helper function in this mod. Yeah, that's what it is. It's a helper function in the module. That's it. Okay. So we still need that. If we get rid of that, it should main should go red. Yeah, main's red. Can't find it. It's private. Change visibility. We don't need the pub crate thing, so we're just gonna manually do it here. Pub function. Good. Alrighty. Sorry, that was a long section of stuff there with like no break. There wasn't a lot of like text in the tutorial. Okay, so something's broken though. We went out of bounds. Here somehow. What? How did we go out of bounds? We have lots of error checks, and now it's working. Hitting the orc, and they died. Just like that. They don't currently hurt the player, so we can win everything, and that's about it. Alrighty. Why did we go out of bounds? Something wrong with my map gen, maybe. Let me scroll back up. Index is out of bounds. It's on this line. 4069. Apply room to map. And then we loop through. Let me compare some things real quick. Y map. For y in room.y y1 plus 1 dot equal room.y2. For x in room.x1 plus 1 dot equal room.x2. Let index equal self.xy index xy. Self.tiles index equal tile type dot floor. Okay, so that's fine. So what that tells me is that, let's go to uses. The room did not generate properly, so Y room to map. Right. So let W RNG range min size to max size, for W and H. X is RNG range 1 map width minus W. I thought it was capital and that was like, oh, that's weird. We've been fortunate that we haven't hit that typo yet, but there was a typo here. We were using height minus W instead of height minus H. And a new room is XYWH. So then what'll happen is sometimes it'll generate something there that isn't really good. Okay. This hasn't happened yet. Took many, many runs before it happened, but there was a slight typo there, which, you know, happens. You're talking as you're typing code, things happen. Alrighty. A lot of stuff went on there. Tusk is enjoying Mafia 3. Okay, let's kind of back up a little bit. Just reiterate over everything that just happened, because there was a lot of stuff there. I did most of it without like stepping back to this because there wasn't a lot of text, right? So we had added a once to melee component, which tracks who you want to attack. We have a suffer damage component, which builds up a vector, which is used to accumulate the damage. Again, I'm probably going to do this after stream. I'm going to try switching that to an int, unless I see a reason not to. I'm just curious why it's a vector. So my question is basically, what we do is we push things into this vector, but I don't know why you couldn't just take suffering.amount plus equal some number and just keep accumulating into an I32 instead of building up a vector. I'd like to see if there's any major difference between the two. If I run into any issues using the vector or whatever, just out of curiosity. But we have this vector that accumulates our damage that something is going to take. And basically what we do is, if something should take damage, we check to see if it already has the component, and if it does, we just push into that vector. If it doesn't have that component, we actually insert a new component, which is what store.insert is. We insert that that suffer damage component onto the entity with a new vector with how much damage they're set to take. Then let entities, what is this from? This is the player movement. So basically, if the player is moving onto an enemy or onto some kind of entity that they can attack, which is basically this right here. So for a potential target in all the contents of a tile, we try to get their target info, right? Their combat stats, rather. We try to get their combat stats. We call it target. And then if they actually do have combat stats, we build out that once to melee component, right? And we basically insert that onto the entity. Then this is where it got beefy. We did the melee combat system, and it uses the new damage system we created. So let's see. So this system, when it runs, we get entities that want to melee, that have a name, that have combat stats, that can inflict damage, or that are inflicting damage. So inflict damage, to be clear, is suffer damage. Okay. And then we basically say, if our current thing has health, then we get our target. And if our target has health, then we get their name. We figure out whether we deal 0 damage or some positive number of damage. If we deal 0, we say we're unable to hurt them. If we do deal some damage, we actually create that suffer damage, and it gets attached to the entity. So, so what's happening there is, well, I should say we're not creating necessarily suffer damage. We're adding damage to the suffer damage component if it exists, or we're creating it, and that's back up to this function here where we just broke down this is new damage, right? So again, if there already is a component, we push onto that vector. Otherwise, we modify the value. There's a lot going on. There's a lot of things interacting with each other right now, and that's why I'm breaking it down. So that's all of that basically. And then we clear once melee because it's already, it doesn't want it anymore, right? So, and then the damage system. That one's simple. We just get everything that is suffering damage and has combat stats and just accumulate and apply the damage to their health. And we clear the damage. We also add a method to clean up dead entities. And for that, we just get everything that has less than 1 health. All the entities with combat stats that have less than 1 health, put them in a vector of dead entities, and then we remove them from the ECS. We delete the entity. Now, we probably won't want to do that forever. We might want to leave corpses and stuff, but this is a thing for now, right? This is an option for now. So you've already seen me run it. I could run around and hit things and they vanish when they died. I'll do it again real quick because I just talked about a lot of stuff. So let's see it in action one more time. We also found a bug. Boom, I hit him, I hit him, I hit him, I hit him, and he's gone. He's all gone. That's all we need to see there. It's pretty simple. So now, we're almost done with this section. Told you it was going to be a long one though, it's over 2 hours. Letting the monsters hit you back. Since we've already written systems to handle attacking and damaging, it's relatively easy to use the same code with monsters. Just add a once to melee component and they can attack and kill the player. We'll start off by making the player entity into a game resource so it can be easily referenced. Like the player's position, it's something that we're likely to need all over the place. And since entity IDs are stable, we can rely on it existing. In main.rs, we exchange the create entity for the player to return the entity object. We then insert it into the world. So it's still part of the ECS, it's still being inserted like a normal thing, but then it's also being given as a resource because it's the entity ID basically. Where is it at? We're not in main, that's where it's not. That's where it's at. So here's the player. And does this return? No, it doesn't. So let's see. We're going to use something a little bit different, aren't we? Oh, no, that's the point. Yeah, no, that's fine. We need to go down here. Create entity. It returns the entity builder. Build returns the entity. So that's probably all we're changing is we're actually capturing it. So let player entity equal GameState.ecs create entity with position, with renderable, with player, with view shed, with name, with combat stats, and build. Yep, I'm happy with that. And then we insert it into the world. So we'll go right down here and we'll say gs.ecs.insert player entity. Now this is the resource one, and you can only have one resource of a given type. That's my understanding, which seems a little odd to me. If you wanted multiple resources, I guess you'd say vec, whatever. So entity, right? So instead of player entity, it would be let. Well, I'll just do it this way. Let player entity vec entity equal vec player entity. Whoops. Like that. And now we're actually inserting a vector of entities. I know that's not what you'd call it. That's not good code. But the point is, if you wanted to store multiple entities as resources for whatever reason, that's how you do it, I guess, right? So if you need more than one of a type, that's what you want to do. So just remember now, anytime we get a resource, if we say entity, we're actually saying that's the player. That's the trick. So now we modify the monster AI system. There's a bit of cleanup here, and the hurl insults code is completely replaced with a single component insert. Monster AI systems. Also, I feel like I may have added extra files. Let me double check something real quick. Components, damage, main, map indexing, melee combat, monster AI, player, rect, visit. No, we're good. Okay, yeah, we're good. Looking at it on their side versus my side, it looked different. Okay, so oh my goodness. Yeah, they're adding the clippy one here because it's definitely getting beefy. So write expect map, read expect point, read expect entity. So again, read expect is the resource. So expect ones are resources, and storage is regular storage things, regular entities and components and all that good stuff. Or regular components. So this is the player. That's the trick. Read expect run state. Don't know what that is yet. We brought it in. Okay, whatever. Oh no, that pulled in from super. Let's do it that way. They pulled in from super. Run state was the enum that was like we're using it to determine whether the game is like paused, you're taking a turn or whatever. Okay, so we get that. I didn't know that was being inserted as a resource. So I guess we're gonna have to do that. Entities. And then write storage view shed monster. We don't need name anymore because we're going to do that elsewhere. The other systems can get access to the names when we're saying like so-and-so attacked so-and-so. We don't actually need that here. So now we got a big old beefy boy here, and I kind of want to copy it because it's just, yeah, I'm going to be a little lazy on this one because that's a very, very long line. And why are you mad? Okay, that's because of down here, right? Oh wait, no, hang on. Make sure I didn't miss one. Map, point, entity, run state, entities, view shed, monster, position. Oh, it wants to melee. I missed one, see? So there's something interesting here. I think Rust stops, like, it only does tuple implementations up to like 12 or so. So if you want to take that like system data, like data dot, see how it goes up to 8? I think it only goes up to like 12 or so, because those are like hard coded into the how tuples work. So it's interesting. I wonder if I don't know. Let's say probably do some macro stuff to generate more dot numbers if you want. Okay, and now none of this stuff lines up anymore, so let's see what we need to do to make this happy. For entity, view shed, monster, mute position. Okay. So then what do we have here? And entities, and mute view shed, and monster, and mute position. So the reason I copied that first line there is because it's not like, there's nothing special about destructuring the tuple, and it's getting so long, it's actually difficult to copy it between the two here. It's more prone to error, it's just time consuming. Nothing special about destructuring it. So I'm gonna just go through line by line. Let distance equal Pythagoras 2D, point with position X, position Y, player position, okay. If distance is less than 1.5, yeah. If distance is less than 1.5, attack goes here. So we now say once to melee dot insert entity wants to melee, and then it's going to be star player entity dot expect. Maybe like unable to insert attack. Yeah. And then also view shed contains player position, path to player, A star search, blah blah blah. All that looks fine to me. If path success and path, okay, there's more going on here. Let mute index equal map dot xy. Where? Oh, did I type something wrong earlier? Because it didn't complete and it threw me off. Did type something wrong there. I swear I type better than this when I'm not talking. I'll get better over time, I guess. Map.blocked idx equal false. I gotta break down why we're doing this here. Position x equal path steps, I32 mod map width. Yep, same thing there. Index idx equal map dot xy index position x position dot y. Are we doing that again? Oh, because we are changing position. Okay, yeah. Again, do this while you're like talking and stuff. It's not as easy as I would like. Alrighty, so I think this part's fairly straightforward. This wants to melee. I think the most difficult thing about this, also I don't know why run state is here. We're not using it yet, so I guess it'll come up later. But wants to melee to me is the most difficult part. This is the key though. Wants to melee is our right storage, right? It is a right storage. So we're saying we want to put a new wants to melee component in there, and we're inserting for this entity, saying that it wants to melee this entity. That's all that has to be done, because once it actually tries to do the melee with the melee system, that's where all the code to actually do the stuff is at. So that's actually really nice. You're literally just saying, hey, attack. Something else will figure out how to do the attack. Now, what's going on here? If we can path, basically, and it's greater than 1 away, we get the index. And we say that next thing is not blocked. Oh, because we're... Okay, yeah. I see. We're saying the place that we're currently at is no longer blocked. And then we update the index to where they're about to go. That's what position X equal path steps and position Y equal path steps. That's what that's about. That's the next position. And then we get that map index. And then we set that one to blocked. So we're just updating what part of the map is blocked. Cool. I didn't realize we weren't doing that before. I guess that's my biggest question. What were we doing before? Oh yeah, we straight up just were not doing any of that. Okay. Find it interesting that we didn't update that until now. Because that is the cleanup code that was mentioned. So if we cargo run now, we can kill monsters, they can attack us. Or we crash again. World is completely empty. Did you accidentally create a fresh world? I would like to know where that's empty. It's the run state. We haven't inserted run state. What I'm going to do is where is it at? We're going to put that there, and we're going to put that there. I was actually questioning that earlier. We haven't even done that, have we? Yeah. A little problem in the tutorial. We adapt. So the orc is hitting me. I'm going to fight him. I emerge victorious. I have no idea what my health is at, but it's getting pretty low already. We're going to go until we die. Yep, and I died and the game was mad. We called an unwrap on a none value when something tried to hit me. So that's, I already called that out where I was like, unwrap is dangerous. That's not how we want things to go, but that's fine. I'm sure they'll clean it up. It's just, we died. And then there is no more combat stats here. So, yeah. Game is mad. Alrighty. There's a lot of changes, but we're almost done here. So yeah, I don't think I need to really go over this too much. We already, I mean, we just did it. Player entity is a game, is now a resource, and we're taking advantage of that here. And the biggest change is that once to melee insert. Again, I'm going to call out what's happening is they do have this read expect run state, which is a resource. And then they're unpacking it here. It's not being used, but that causes a crash because we never inserted that resource. I'm not sure why it's being mentioned. All we see here for resource is player entity. Probably going to use it in a minute, maybe. That's what I can imagine. Oh, actually, yeah. Never mind. So if a monster kills you, the game crashes. Oh no, that's not the run state. That's the unwrap that we just had. Yeah. It crashes because delete the dead has deleted the player. That's obviously not what we intended. So here's a non-crashing version. Probably just exclude the player. Where's delete the dead? Right here? Yeah. Okay. So what are we going to do here? We do the vector, combat stats. Now we're going to get players. Let players equal ECS.read storage. We're going to get the player component. And we're going to get the entities. We're already doing that. If stats, blah, blah, blah. And then we're going to say let player equal players dot get entity. So whatever current entity we're on, we're going to attempt to get that player from it, the player component. And if it exists, that's the thing that we care about. So what we're going to do is match player. Say none dead.push entity some body, no, console log, not long, log, you are dead. For victim and dead, blah, blah, blah. We don't have console, so let's include that. We should really include that in main and like export it from main so everything else can see it. We could do that, right? think we can. If I just do use... I don't think that works. Because we're having to do RGB in other places. Whatever. Not going to worry about it. Alright, so now... if we run it again, we die. Let's quickly speed run this game. Oh, I'm dead. Yeah. I can still move. But I'm dead. Yeah, I mean, maybe that's a feature. So what you'll have to do at that point is have some checks or something in the game to do different behavior, whether they're alive or dead or not. And we'll do that. But the whole thing here says we'll worry about ending the game in a later chapter. If you look closely, you'll see that enemies can fight back even after they've taken fatal damage. While that fits with some Shakespearean dramas, they really should give a speech. It's not the kind of tactical play that roguelikes encourage. The problem is that our game state is just running and paused, and we aren't even running the systems when the player acts. Additionally, systems don't know what phase we are in, so they can't take that into account. Let's replace run state with something more descriptive of each phase. And this is where it gets a little interesting, and this is where we're going to use it. So we're going to have a waiting input, pre-run, player turn, and monster turn. If you're running Visual Studio Code with RLS, half your project just turned red. That's okay, we'll refactor one step at a time. We're almost done too. If you look at the scroll bar, we're almost done with this section. So it sounds bad, but apparently it's going to be fine. So where is run state? It is right here. So instead of paused, we're going to do, I'm not going to do any replace. We're just going to do it this way. Waiting input, pre-run, player turn, monster turn. And now things will get mad. It's not as bad as they made it sound. Partial EQ, copy, clone, all that's still good. So pub struct state, we're going to remove the run state altogether from main game state. Okay. That's going to be the resource. Now things are going to, not too bad yet. This makes even more red appear. We're doing this because we're going to make it into a resource. So in main.rs, where we insert the other resources, we add, where are we inserting resources? Here's one. We'll put it here. gs.ecs.insert run state pre-run. Now start refactoring tick. Our new tick function looks like this. We no longer need that. So tick, instead of self.run state, we're going to have to get it probably up here from the top of the function. Yeah. Let mute new run state. Let run state equals self.ecs.fetch. Run state. And then we want new run state equal run state. I'm going to suggest we do this a little bit more rusty. And then this is going to be match new run state. Let's get the match arms. And then if running, so on, let's see. Awaiting input. Actually, let me organize these the same way. So first is pre-run, then awaiting input, then player turn, then monster turn. So pre-run, what are we going to do on pre-run? Self.run systems, new run state equal run state, awaiting input. And then waiting input. Building up a little babby state machine. New run state equal player input. Ah, damn it. Player input. Self CTX. Player turn. Self.run systems. New run state. Monster turn. Okay, so the player took a turn, now the monster takes a turn. That makes sense. And now the monster takes a turn, we go back to waiting input. Okay. Then we're going to do some funky stuff down here. Let mute run writer self.ecs.write resource. Yep. We want to put that in here. Run state. New run state. And then lastly, I just deleted delete the dead. So we'll do delete the dead here. No, and mute self.ecs. Alrighty, so I'm okay with this, but I suggest we do some of this a little bit more rusty. For instance, this here. There's no need to... Basically, we can just say equal. Put this here. Do this. And this. That's a little more rusty, I would say. You may even be able to get away with doing this instead. Put a star on this. I don't know if you would argue it's more or less readable, but we're just fetching the run state and dereferencing it. That's it. So that cuts down a little bit on some of that boilerplate there. And what we could also do here is say, there's a lot of new run state equal, new run state equal. Well, new run state equal that. I don't know if that'll be good because we're matching on something that we're mutating. But I think it's okay. Rid of the semicolons. Oh, whoops. Oh no, waiting input, that's fine. Yeah. So player input returns a run state, and we're returning that, if you will, out of the match. So this is, I feel, a little bit more rusty. We could treat this entire match block as an expression, which what comes out of it, these run states, gets applied to new run state. Just my own little take on this. Not trying to say that the other way is necessarily bad. This to me is a bit, I mean, I'm not the arbiter of what's idiomatic Rust, I guess, but I've written a lot of Rust, I've read a lot of Rust. I feel like you'd see code a little bit more like some of this. This one maybe not, I don't know, this is very specific, but in fact at that point you don't even need to use the scope. That's why I was like, yeah, we could just get rid of that altogether. So I feel like, I mean, this is fine. The other one was fine, like let's make the scope and modify a couple things, but this is fine. Actually, there could be a purpose to the scope there, because it's not complaining though. If I get rid of this, do we complain? We don't, but it might be because, oh actually no, what are we complaining about? We're still complaining about this, so we gotta refactor other things. We might actually need that scope there. So we'll see what happens. Because we're fetching and then we're also writing, so we may need to do that. But it may also be smart enough to realize we're dereferencing that, so then the fetch is no longer a borrow. I don't know. We'll see what happens. All right, me going down rabbit holes. Notice how we now have a state machine going. Hey, I called it a state machine earlier. Cool. Notice how we now have a state machine going with the pre-run phase for starting the game. It's much cleaner and quite obvious what's going on. There's a bit of scope magic in use to keep the borrow checker happy. If you declare and use a variable inside a scope, it's dropped on scope exit. You can also manually drop things, but I think this is cleaner looking. In player.rs, we simply replace all paused with awaiting input and running with player turn. And then lastly, we'll modify monster AI system to only run if the state is monster turn. So we have a snippet. Let's go to player and say running. We'll say run state running. And we'll replace that with run state player turn. Run state paused with awaiting input. That's happy. And now monster AI system. What's mad here? Console? We'll leave it for now. So we did have this here. Now we're going to bring it back so the game doesn't crash. Well, now the game won't crash because we have the resource. And we're going to be using it. And they actually show the... Yeah, they actually show it here. I think there's just a slight mistake. They weren't supposed to show it earlier. Fine, though. And all we're going to do here is... we destructure. We get all the stuff from the data. And then we say if run state, we'll dereference it. If run state not equal run state, monster turn, return. Some people like it. It's in the tutorial like this. Some people like doing returns like this. I think the formatter is going to do this. I prefer this. I think it's easier to read. And then don't forget to make sure all your systems are in place in main. Main is still happy, which I'm interested in. I think it's just because I decided to do the assignment all at once. I think it's satisfied. Run systems. So we have visibility, monster AI, map indexing, melee combat, damage system, and that's it. So if we cargo run, it behaves as you'd expect. If the player moves, and things he or she kills die before they can respond. Let's go ahead and I gotta click back into VS Code and run. Is anything mad? Nope. My little changes are just fine. See? Yeah, and if you looked at if you're looking at the console there, I hit the goblin, but the goblin, like the last hit where the goblin died, he did not attack me after he died. That's the point that we were getting at there with some of those changes at the end. And take care of these last dudes until I die. Eventually I will die. Probably not far from now. I am dead. Very dead. So dead that the game keeps telling me over and over. It's better than walking around like I was earlier. So some of the state stuff that we did, I think, changed that, and we'll clean things up, I'm sure, right? So that's that. That was indeed quite the chapter, as the tutorial says. That was quite the chapter. We added in location indexing, damage, and killing things. The good news is that this is the hardest part. You now have a simple dungeon bash game. It's not particularly fun, and you will die since there's no healing at all. But the basics are there. Well, that was almost 3 hours, but we're going in for the long haul here, and we're doing this. I mean, this is a much shorter section, so it shouldn't be too bad. This is user interface. So in this chapter, we'll add a user interface to the game. So shrinking the map. No, I can barely see it already. We'll start off by going to map.rs and adding some constants. Thank you, finally. Map width, map height, and map count. Then we'll go through and change every reference to 80 by 50 to map count and references to the map size to use the constants. When this is done and running, we'll change the map height to 43 to give us room at the bottom of the screen for a user interface panel. Alrighty. So we'll just go up somewhere at the top. That's usually where constants go. So const map width usize equal 80, height and count, map count usize equal map width times map, or they do height first, doesn't matter. And we'll change that one. And it's going to be 50, not 550. 80 by 50. Do I have any things that's like 80? No, good. I always space mine out. In the text here in the tutorial, though, it shows 80 by 50 with no spacing. So we're going to replace that with map count, right? And references to the map size to use the constants. So 80 is going to be, I mean, I think I can almost just blindly do that here. So map width, not that one. Next. Yep. And yep. And then 50. Map height. And then I need to double check 79. Yeah, so 79 is going to be map height, no, map width minus 1. And this is going to be 49 map height minus 1. That should be everything. We're going to have to do a lot of casting though, aren't we? So expected an I32, we found a U size. Now expected I32 found a U size. What is Y? Ah. Oh, you know what we could do for some of this is actually... That should be fine. What's going on, Omnivore? We could change this to an I32 ink. No, we can't do it that way. Okay, we can do it on there. Good. Alrighty. Let's try to get rid of some of that casting in here. It's a little less clean. There we are. Yes, we still need this where we're using the constants, though. There we go. All right, everything is happy now. Let's run it real quick. Make sure we're good. Yep, okay. Now, once we get those changed, see, I wish we would have done this a long time ago. Like when we were building it, I kept commenting on it, like, oh, we should do that. We're gonna change it to 43. Gives us some room at the bottom of the screen for a user interface. So we're going to do some minimal GUI elements. We'll create a new file, GUI.rs, to hold our code, and we'll go with a really minimal start. Very, very minimal. I'm going to copy the uses, and then we'll add a mod GUI. Yeah, so we'll do all the cool main stuff as well. I'm going to do that to start because I want it to give me the proper like syntax highlighting and stuff in the code when I'm typing things out in the module, that is. So mod GUI, use GUI star. It's mad because it doesn't know what GUI is. Now it does. Pull in the use state, all the use stuff. RGB RLTK console, specs prelude, and then a very simple draw UI function for now. Draw UI ECS world context mute RLTK RL Stein. It's in the game. Was a 79? We're hard coding a lot of values, aren't we? I mean, to an extent, you can hard code some things, but I always think about what if you change your resolution on the monitor? Or not the monitor, but like the game window. What if you change your game window resolution? Okay, we add a mod GUI. Yep, I've done that. We now call this at the end of tick. So GUI draw UI. Let's find tick. And self ECS. What's going on, Ice? How you doing? So, yep, we'll cargo run and see what we got. So we are using Drawbox, which is part of RLTK. It does a little bit of the work for us. Looks like it takes in a couple colors, X and Y positions, and then a width and a height to build a rectangle. Okay. Let's take a look at it. Nope, it is not happy. So we went out of bounds on something. What did I type? Let's see, 0, 43, 79, 6. Went out of bounds on something. In the map, actually. Interesting that changing this map height has created a problem. So let's take a look and see what I've done. The length is 3440, but the index is 3493. There seems to be a potential slight mistake here. Well, obviously, but I caught something in here earlier, and now I did that refactor, and now I'm having the same issue that I had earlier. So I may have missed something in the refactor. But what's interesting to me is the length and index being very close tells me it might be something different. I am using a Visual Studio Code, VS Code. So we have a new room that, actually, let me take another look at the line. Yeah, we're indexing into tiles with what we get from this XY value that come from the room. So the room values have gone out of bounds, basically. They come from, yeah, just come straight from the room. So we'll look at where we apply the room to the map. And we got to make sure these are all factored in correctly. So min size and max size, we calculate from, yeah, these are the sizes of the rooms. And these are just hard-coded constants in here. I haven't had a need to touch these, have I? So I'm wondering, I could probably run it again and it eventually works. It's random, right? Having a hard time getting it to work though. Basically, if I generate one where the room doesn't go out of bounds, if we get lucky, I'll generate one where the room doesn't go out of bounds. I'm trying to see what I'm missing here. I'm not a big fan of Eclipse myself. If I have to do Java, I'd rather use IntelliJ. But I mean, actually, I've done a lot of Java in Visual Studio Code. I started doing that at my last job a bit. It worked out pretty well, but it's because we had Eclipse or Visual Studio Code. But I think IntelliJ is just really good for Java, so kind of the point of it. It's really, really good for Java, so I'd rather just use it than set up Visual Studio Code. I use Visual Studio Code for almost everything, though. If I touch a language, it's not Rust. Which is rare these days, outside of work. So what is this range coming from? Like map.width, it must be that the map, yeah, this was missed. That's all it is. Let's look for 50 again. No. Okay, let's look for 80. That's fine. That's all that was missed. Okay. Yep. There we good. Alrighty. Now we got our box that we expected. Everything's good over here real quick. Yeah. Now we got what we expected, so we can start filling it in with stuff. Alrighty. Does anyone really know Java? Alrighty, some minimal GUI elements. So we've made the GUI.rs, we've added the mod, we're drawing it, and we get this. We've just seen this in action. So adding a health bar. It would help the player out to know how much health they have left. Fortunately, RLTK provides a convenient helper for this. We'll need to obtain the player's health from the ECS and render it. It's pretty easy and you should be comfortable with it by now. Code looks like this. So we're going to add this into the draw UI. We're going to need to reference combat stats and player. Let's go ahead and start working on that. Where is my GUI? Over here. So we have console, RGB, RLTK, that's good. Use super, combat stats, and player. So now we still take the ECS in the context. Nothing's changed there. We still draw the box. That's all good. So now we're actually going to start working with these components. So we're going to get combat stats. Let combat stats equal ECS.read. Yeah, it's read storage. It's not a resource. So we're going to get read storage. And it is combat stats. We're going to do this again for the player. So I'm going to be lazy. My double click didn't go through though. We're going to get combat stats and we're going to get players. And then for player and stats, so we don't actually care about the player. We just care about the stats, but we're having to join the two together. So players, combat stats, join. Okay. So yeah, this just gets us, in this case, we know we only ever have one player, so this works pretty well. If you had a multiplayer game, which doesn't make sense for a roguelike usually, I guess I think there are a couple that exist that are kind of weird, but I actually saw a multiplayer Cataclysm mod, now that I think about it. Didn't look much into it, but I think what happens is it like blocks off sections of the world that are like your space, and everything in that section, they run separately from each other. It's something weird. Let health equal format So what do we want? We want HP, something out of something, stats.hp, stats.max HP, right? And then we're gonna print it. So context.print color. 12, 43. Also, there are basically two standard ways that people write Rust. The way that I would say probably like 80-90% of Rust writers do is with Visual Studio Code. It is just what people do. It's ubiquitous. But the other one is with another JetBrains project or a product called Sea Lion. And Sea Lion, actually, I think IntelliJ also has a Rust plugin, but Sea Lion is the main one that people use if they're using like a bigger named IDE. But honestly, most people don't do that when it comes to Rust. It's literally like just VS Code across the board. It has really, really good support. So we're going to draw bar horizontal, 28, 43, 51, stats.hp, stats.max HP. We're going to get red. And what's the background? Black, yeah. That's a big beefy boy. So we got a bar. That's nice too, because it basically just does a percentage and everything for you. Yeah, so draw the bars. Pretty simple, pretty straightforward. Yeah, I don't think there's much to say here. Again, just breaking down how the ECS works though. We get the join of the players and the combat stats components. In this case, because we know there's only one player, that's only going to be a single entity. And so we just grab the information we need. We grab the stats, HP and max HP, and we print that out. And we basically use that same information to draw a bar. So if we run it, we should see this in action immediately. If I didn't break something. Yeah! Let's go take some damage real quick and see what happens. Yep. Look at that. Ah, it's beautiful. Absolutely beautiful. We're almost dead. And we're dead. Okay. Scoot this back over. Well, I would say that's... I mean, it's not... Yeah, I guess Eclipse is open source. I guess because there's like Spring Tool Suite and stuff that's built off of Eclipse. Visual Studio Code is so good though. It's very lightweight and fast. It's a lot faster than Eclipse, and it's exactly what you want it to be. Like it comes with like very little, and you just add what you want. You add the extensions to do what you want. And they're the ones responsible for the what's it called, the language language server LSP, language server protocol, which is just like the best, like pretty much the best kind of autocomplete these days. It's so fast, it's so good. Autocomplete and like the inline errors and everything. Like if we go back to the code real quick, and I say let j i32 equals test. It's not an i32, so we get the inline error and stuff right here. Oh, guys, like Visual Studio Code's so good. I just hate trying to do like C or C++ in it, but you can do it. But I hate having to set up the build stuff for it. Alrighty, adding a health bar. We just did that. Adding a message log. Game log makes sense as a resource. It's available to any system that wants to tell you something. There's very little restriction as to what might want to tell you something. We'll start by modeling the log itself. Make a new file, gamelog.rs, and we'll start very simply with a gamelog struct. And in main.rs, we'll do the mod and all that fun stuff. Okay, so let's get going on that. And we're going to insert it as a resource with something much more complex than what we've done before. Basically, it's not just inserting an empty resource. We're going to initialize it with welcome to Rusty Roguelike. And then we'll just be able to display that from the start of the game. Okay, so then we'll write the display code. Let's check it out. What are we going to call that again? Gamelog.rs. And in main, plop those in here real quick. Guess we don't need to. That's fine. We don't actually need to be using GUI like that, but I'll leave it for now because I don't know how much we're going to be changing it. Where's gamelog? What do we need in here? Not much. So pub struct gamelog. It's a vector of strings. And back in main, what are we going to do in main? We're going to insert this here with these other, is a resource, right? Yeah. gs.ecs.insert. And it's going to be gamelog. And I'm just going to have this autocomplete help us out here. And it's going to be a vector with welcome to Rusty Roguelike to string. And we already kind of talked about that. So now in our GUI drawing function, we're going to have to get that resource. So we'll probably do it up here with the players and stuff. Let log equal ecs.fetch game log. We're going to have to add that at the top. So I'm going to do super. Yeah, it's in super. Okay, so we fetch the game log, and then we do let mute y equal 44. So again, we're hard coding a little bit of location and stuff, which that's okay. S in log.entries iter reverse. Now that's actually important. That's important because we want to display the newest messages first. Imagine if you've been playing for an hour, you don't want to see the first message in the game because you're going to run out of room. You only want to see the new messages. So we're going to reverse that. And then we're just checking the location to make sure we can print something. And that's about it. Not too much going on there. So we'll now run it and see what we got. Click back in though. We are. Welcome to Rusty Roguelike. And nothing else is really using it yet, so we shouldn't expect to see anything else. But we got it. We got something going. It's looking much, much better already. No, that's fair. I mean, use what you want to use. I'm somewhere in the middle on Eclipse in terms of hating it, because it's very, very hated in the industry by a lot of people. I'll say that. I'm in the middle on it. I don't think it's as bad as a lot of people say it is, but I'm not a big fan of it. That's all. But I mean, you use what you like. I don't like. It doesn't hurt me, right? You're not like you're not holding me at gunpoint saying you got to use Eclipse. I don't really care. I'm not trying to say it like, you know, in a way like I'm mad that you use it. I'm just saying in general, I'm somewhere in the middle. Like I'm not super opinionated either way. I'd prefer not to use it personally, but I mean, I've used it. It's whatever, you know. I'm pretty indifferent. Logging attacks. In our melee combat system, we add game log to our imports from Super. Add a read-write accessor for the log. Write expect. Okay, yeah, so we're doing a write expect for the resource. And extend the destructuring to include it. Then it's just a matter of replacing the print macros with inserting into the game log. Okay, let's check it out. Yeah, so I mean, there's also the fact that there are a lot of versions like I use Spring Tool Suite, which is based on Eclipse. I've used that in the past, and most of us that had to use it, we were not really happy about using it. I'll say it that way. That's not just regular Eclipse. That's Eclipse with some extra stuff thrown on it, and we didn't have a very good time with it. It, you know, had crashed a lot and all that. But that's what gives a lot of people a pretty negative opinion about it as well. Is when you deal with like crappy versions of it, it's not it's not fun. And you know, it's not 100% fair to blame it, but you know, it is what it is. Game log wants to melee name combat stats. So then we got to destructure it, so it's right after entities, so we say mute game. How are we going to call it? Just say log. Mute log. So we'll destructure it out of there. And then where we have the console logs, we want to do log.entries.push. And then it's probably just a matter. Actually, can I just kill that? If I can type. Expected string, we found a reference to a string. Right, we'll kill that, and we'll kill that. I think that's it. Yeah, should be it. Let's check it out. There we go. Boom. Just like that. Very simple change up. Didn't really take a lot to get that one going. Much better than printing to the damn console. Alrighty. Let's take a look. So now if you run the game and play a bit, cargo run, playing is up to you. You'll see combat messages in the log. Yep, we just saw that. Cool. So now we're going to notify of deaths. We can do the same with delete the dead to notify of deaths. So it's going to be very, very quick. Simple change here. You mentioned PyCharm. I think I used that one time. Where is delete the dead? Damage system. Yeah, I think I used that one time. It's been a very long time though. Again, I don't really use Python. I don't really like Python. But when I first started doing, when I first started working in the industry, we used IntelliJ. And I was like, oh, they have like all these other things. Let's read storage. We can't find name, so gotta pull that in. We need game log too. Yeah. So we're using IntelliJ, and I was like, oh, JetBrains makes all these other cool things, and if I need to write some Python, let me try like PyCharm. They have WebStorm, so I was thinking like, I'll try all their stuff, and it was like okay, but again, I don't like Python, so I don't really have much of a use to. I don't have much of a need for something like that, and once I started using VS Code, I was like, yeah, that's perfect for me. If I need to touch Python, that's how I do it personally. That or just idle. I actually don't mind using idle because if I'm using Python, it's going to be something like very very quick. I don't need an IDE for it. I don't need like much of an IDE at all. If I'm writing more than like 6 lines of Python, I think I'm doing something wrong. All right, so our none branch here is going to be a little bit beefier now. Let victim name equal names.get. So we're just ripping it out of the ECS again. Whoops, if I can type. We're gonna do an if let here. If let some victim name. I like, now that I finally understand if let, I can do it, like I've been doing it in some of my own code. Now that I finally understand the syntax and know how to use it, like I'm a big fan of it. So convenient. So whatever it is dead. Victim name dot name. Oh, that's where I was like, yeah, I thought I had an extra parenthesis. There we are. Dead.push entity. Still have the console log showing up on the URDEAD part. I'm not sure why. I feel like we'd also want to push that into the logger deal. Let's do it real quick. I'll leave this on the console because they didn't change it in their code, but I'm gonna put it in because I think it'd be better to have it in the game. Oh, I think I know why they're doing it though. Because of the way the system is right now, it's gonna spam. You is dead. I'm gonna leave that. You is dead. And we don't need an argument now. You is dead. Let's try to get ourselves killed real quick. Alright, 1 or 2 more fights ought to do it. You is dead. Yeah, the way the system is right now, it spams it, so we'll probably clean that up over time. But I'll comment that out just so it doesn't do the spam. It's fun. Oh, Python's your main language. I'm so sorry. Why would you do that to yourself? Let's start by looking at how we obtain mouse information from RLTK. It's really easy. Add the following at the bottom of your draw UI function. So we're going to draw the mouse cursor. Okay. You like Python? Why? It's like gross and like dynamic and stuff. Interpreted. Like dynamic is like whatever. It's all interpreted. That's the terrible part. We're going to set the background of the cell at which the mouse is pointed to magenta. As you can see, mouse information arrives from RLTK as part of the context. Now we'll introduce a new function. Draw tooltips and call it at the end of draw UI. New function looks like this. New. Let's get over to draw UI. Where are we at? Add the following to the bottom of it. All right, we'll do that. We'll get the mouse position from the context. Mouse position. I always find it weird when roguelikes actually have mouse input. It's just so different. We're going to do RLTK magenta. That's pretty straightforward, isn't it? Sets the background of the cell at which the mouse is pointed at to magenta. As you can see, mouse information arrives from RLTK as part of the context. Now we'll introduce a new function, draw tooltips. I want to see this in action real quick. Oh yeah, it's very quick, very easy. Nice. So we're doing that kind of over everything. Yeah, it's kind of cool. Okay. And that's a beefy one that we're introducing here. We're going to call it at the end of draw UI. So it's going to be a function called draw tooltips ECS world. Oh my god. There we go. Also, oh no, I'm not defining it. Stop that. Why did I do that? You know what? Let's just copy that. Fine. I was gonna just call it there and be ready to go, but we basically just defined it. Alrighty. I wasn't thinking. I'm rolling with it. This is a big beefy boy. So let's kind of break this down. We're gonna get the map. So we're just gonna fetch la mapa. We're gonna also get names and positions. So position and name. Let's bring in map name and position. And now we get the mouse position back from the context. If mouse position dot 0 is greater or equal to map dot width, or mouse position dot 1 greater or equal map dot height, we return. Now what? We're going to make a mutable tooltip, which is a vector of strings. And we're going to loop over name and position. So we'll join that up. We'll loop over them. We'll get the index of where we're at from the map.xy index function thingy. It's going to be position.x and position.y. If the position.x is the mouse position, 0 and position.y is the mouse position.1, and it's visible, map.visible tiles on that index, no semicolon. I gotta scroll real quick, but I think that's it. That's all we're checking. So we're gonna push in a tooltip. Name.name to string. Why are we mad? I missed something. For name and positions. For name position in names positions dot join. Make sure I did some. Oh, we're not fetching. I made a dumb read storage. Read storage, yeah. We're fetching the map. I got lazy on those lines. That's better. Okay. So we push in a tooltip of the name. So that's the first thing we're going to do here. After this for loop, if the tooltip is not empty, let mute width I32 equals 0 for s in tooltip.iter. Iterate through this bad boy. Width is less than s.len. I32. Then after this, we're going to do... We're going to have to break down a little bit of why this value is being used here, but I want to break down like this entire function when I'm done with this, because this is a beefy boy. I'm going to go through almost line by line and just break down the functionality. As I always say, when I'm sitting here like writing this, it's easy to get, you know, more focused in and like tunnel vision on what I'm writing, like getting it typed out rather than how it functions. So I want to take that time to go through and just break down what it actually does after the fact, because again, this is a big beefy boy. If mouse position 1, or no, 0 is less than 40, let arrow position equal point. So we're going to make a point from the mouse position to mouse position 1. Okay. There's a little hard-coded values that I think we're just going to have to figure out. So I'll say it this way. When you're doing UI stuff, there may be some like hard-coded things that you fine-tune. So what you do is, what if I put this thing at this position on the screen? What does it look like? There's a little bit of that, and that's probably some trial and error on how some of these values were determined. We'll see how the arrow position is being used, maybe. So I don't know what left X is. Let mute Y. Mouse position. Dot 1. For S in tooltip.iter. So S is the tooltip. What are we doing with it? Why is it called S? Because it's a string. So this is left X. This is Y. This is RGB named RLTK white. RGB named RLTK green. And then output, I guess, is going to be S. Check. Yes, it is. Now we're going to do some padding and stuff. Let padding equal width minus s.len as I32 minus 1. For I in 0 to padding, context.print color arrow position x minus I y RGB named RLTK white RGB named RLTK something I can't read gray EY. They must be from Europe. I just put that empty string. That is padding again, so just put a space, rather, not an empty string, but a space. It's going to pad between different things, okay? This is the end of the for loop, so now we do another print. I'm getting tired of doing print color, I'm going to be honest. So many parameters. Arrow position.x, arrow position.y, RGB, and then it's doing the RGB named thing over and over too. Oh wait. Oh no, we're good. Okay. So this is gray again. background is... No, see, I feel like I'm missing something. Hang on. Arrow position X, arrow position Y. Why do I feel like there's an extra parameter that showed up? I think we're okay. I think I added something in there when I was typing. Okay, so still not done. Now we have an else block with a bunch of crap too. So what is this else block? That's something we already need to break down. If the mouse position is greater than 40, we're drawing it to the left. If the mouse position, okay, I think we're then going to draw it to the right. I'm going to go out on a limb and just copy this and try to edit it and hope I don't break something. I think that's what we're doing. Basically, if we're getting too far to the right side of the screen, we want to draw the tooltip to the left of the mouse. If we're getting too far to the right, to the left of the screen, we want to draw it to the right of the mouse. So we're going to get arrow position, but we're going to do 0 plus 1. And let left x equal mouse position dot 0 plus 3. Y, okay. And then for s and tooltip dot iter, left x plus 1. I think everything else is going to be the same there. We'll do some padding. Width s.len minus 1, same thing. For I in 0 to padding, we're going to do arrow position dot x plus 1 plus I. I think we're probably factoring in for the mouse as well. We'll see how it ends up looking. Then y plus equal 1. Arrow position x, arrow position y. That's a big beefy boy. That's it though. There's a breakdown in the tutorial as well. I'm going to break it down on my end and then we'll look at that. We got to draw tooltips down here. Draw tooltips. Yeah, that's all we need. Okay, so what are we doing here? We get the map, we get all the names and positions, and we get the mouse position. The mouse position is outside of the, yeah, if it's like greater than the width or the height, we return. Not sure why we're not checking for it being less than 0. Are they, they're I32s. We'll see. We'll try to break it down. We'll try to figure it out. So let mute tooltip is just a vector of strings. And what we do is we go through all the names and positions. And we get the index of it. And if it's on a visible tile, we put the name in the tooltip vector. That's all we're doing. Push the name in the tooltip vector. So now we have a vector of all the names of the items where the mouse is at if the mouse is on a visible tile. If the tooltip's not empty, we want to get the width. We want to set width to 0 and then iterate over all the strings in tooltip. If the width is less than the length of one of the strings, okay, I know what we're doing. We're defining the width of the tooltip box, aren't we? So we're looking basically for the longest string. There's actually some more functional rusty ways we could do this, but this is a bit more C-like. Basically, we look through, and if the current string we're at in the iteration is greater than the width that we currently have, then we update the width so we're basically, again, getting the longest length of all the strings. And then at the end, we add that extra 3 to the width, because I guess we want the tooltip box to be a little bit larger than the stuff we're printing. Have a little bit of boundary on each side, right? So that basically gives us like 1 extra on each side with the third one in the center. If the mouse position is greater than 40, and this is what I described earlier, so we're only going to break this down one time, because the other one, this else clause is basically the opposite. We're just flipping it to the other side, so we only need to really break it down once, I think. So if the mouse position is greater than 40, meaning we're to the right side of the screen, then we want to draw the tooltips to the left side of the mouse, because we don't want to like draw it off screen or something, right? So let the arrow position equal mouse position. Now this -2, not exactly sure where that's coming from. I think it's literally just something trial and error to figure out like where the actual like tip of the mouse is pointing. I think that's what it's supposed to be. And then we get left X is based off of that mouse position as well. Mouse position minus width. Yeah, the width of the text box. Okay. The width that we just defined here. Or the tooltip box. And then Y. Yeah, so this is saying we're going to start it at this X and Y value. This is where we're going to draw the box. We're going to draw all the tooltip stuff. Okay. Then we loop through all the strings and we print them out, right? Print it out, then we do some padding. Yeah, that's all we do. We print a string, we define some padding for the width, based on the width minus the current string's length. So what we're doing is we're writing the rest of the line. Okay, yeah. So imagine width that we defined earlier is 27, but our current string is was it Yojimbo? So then padding is going to go through and put a bunch of spaces in until we get to 27. So what it's going to do is s.len is however many characters are in Yojimbo. So it's going to be 27 minus 7 equals 20. So this is going to be like that. That's our padding. That's crude, but a crude way of describing it, but it works. So we basically just print that, draw that padding out, and then we increment our Y. So that's ensuring that all of their entire text box is uniform. Otherwise, each line of the text box would be a different length. That makes sense. Because we got to remember, we're drawing a foreground and a background here. So that background is still going to exist even under these space characters. So we're going to have a big gray box with text on it. And that's about it. After the for loop, we print this arrow. And I'm not sure why. I guess it's just for look. I mean, it's not going to do anything. I guess it's just for look. That's a big old beefy boy. Let's read their description real quick. I try to break it down line by line. So it starts by attaining read access to the components we need for tooltips, names, and positions. It also gets read access to the map itself. Then we check that the mouse cursor is actually on the map and bail out if it isn't. No point in trying to draw tooltips for something that can never have any. The remainder says if we have any tooltips, look at the mouse position. If it's on the left, we put the tooltip on the right, otherwise to the left. If you cargo run your project, it looks like this. So you can see the spoiler there. We're going to run it here and take a look. I'll try to respond to the... There it is. A little hard to read. Doesn't help that it's super tiny on the main monitor as well. It's easier for me to look at OBS where it's blown up. But yeah, we got it. Okay. I mean, that's cool. I like it. maybe make it a little more legible at some point or whatever, right? Trying to catch back up on these, and it's been like a little bit since those last messages, but that was a big thing. So if you're still hanging out, Ice, sorry about that. You don't necessarily have to learn Java. It's around in a lot of places, but I don't think you have to learn it unless you know you're going to in school or something. I didn't know Java, and my first job in the industry used Java. So I went in and I was like, I'll figure it out. I'd done a little bit of Android development for a couple projects and stuff. And I wrote Java like C++. I was like, I'll just write C++ until it works. And it always got me through Java. It always did the trick. And then there were some weird oddities and stuff that I learned once I was in the industry, and like I had to write Java. And people were like, oh yeah, you do this thing and that thing, and there's like interfaces and all this weird object-oriented stuff that I don't like. But like, yeah, it was easy enough to figure out. Like, once you know one language, it's pretty easy to learn others. Ooh, now we're gonna get somewhere. All right, we're almost done. By the way, the scroll bar shows we're at the very bottom. Also, actually, one more thing I'll say. Yeah, I'm not really a fan of Java myself. Not much of a fan of C# either. I don't like a lot of the forced object-oriented stuff. Not a big fan of object-oriented programming in general. Definitely don't like the forced nature of it in like C# and Java, but I do like C# a little more than Java. It's a little bit nicer, I think, but not that much of a fan of either. Definitely, like, if you're gonna give me something that's not Rust, give me C, and give me C-styled C++. Or give me something weird like OCaml or whatever. Like, I'll have more fun with that. Dude, I hate object-oriented programming. Omnivore loves it. I'm like, nah, keep me away from object-oriented stuff. I think it can be useful sometimes. I think there are cases where, I'll put it this way, you should look at the tools you have and figure out what works for the job that you're trying to do. So I don't really want to say never ever touch it necessarily, but I'll say almost never touch it. Really don't like object-oriented programming. Not a fan. Never have been. I understand the why it's attractive to people, but just no. And again, I like, so I know, like, here's the way I say it too, like with the forced languages like C# and Java, you could write like a class and then just make a main function and write it very imperative style and just pretend there's no classes or anything. But I hate the fact that I have to make a class to print hello world. That's just, why? That seems like terrible design to me. I like more functional style stuff, and that's why you'll see me doing a lot of functional type Rust. And I will, like, I mentioned like OCaml, Haskell, I like stuff like that. I like regular old, plain old C, big fan of that. But I think object-oriented is my biggest beef with it. This is not, again, not a jab against the paradigm in and of itself, because if it is a good tool for the job, then that's good. But I think it is crammed into too many places where it doesn't need to be. So what I mean by that is at the enterprise level, Java basically created the need for object-oriented programming. In the 90s, Java had this like massive advertising budget and everything, and they shoved their way into the enterprise, and suddenly all the big corporations thought, we need object-oriented programming, we need Java. And that's why a big factor of why it became such an industry standard. But what you often see is directives coming from the top down of saying, oh, we got to use Java, we got to do OOP and all this, because that's what's popular, that's what everyone does, right? And in a lot of cases that prevents, maybe there's a better paradigm, maybe there's something better you could do, and guess what, you're not doing it. Because you're being told from the higher up, you got to use Java, you got to do this thing or that thing. So that's part of the issue that I have with it. And I think you see that a lot in like education as well, where that's the first thing a lot of people jump to in terms of like, we're going to teach programming, so let's do everything object-oriented. Like, we're gonna make a calculator now, so let's start making a calculator class or whatever. It's like, I just feel like immediately jumping into OOP with every problem is a bad approach. Like, especially if you want to be a software engineer, like, maybe consider other approaches. And sometimes object-oriented programming is good, sometimes it's not. Sometimes it makes things more complicated. Sometimes it's less efficient. Meaning a lot of the ways that you organize things in object-oriented programming, you can run into a lot of inefficiencies or a lot of terrible like inheritance issues and stuff. And one of the big things that's really shown up in game programming, game development, is data-oriented design. And it's a bit antithetical to object-oriented programming in that rather than organizing things in the way a human thinks about it with what's kind of popular with object-oriented programming, you're thinking about how the computer sees data and how the computer reads and uses that data, and you're organizing your code in a way that that is more efficient for like cache accesses, auto vectorization, all kinds of cool stuff like that. So you can get much more performant code. So I'm gonna catch up on all that in a moment. We're right at the end here, so let me wrap this up. Actually, I didn't read this yet. Optional post-processing for that truly retro feeling. Since we're on look and feel, let's consider enabling an RLTK feature, post-processing, to give scan lines and screen burn for that truly retro feel. It's entirely up to you if you want to use this. In main.rs, the initial setup simply replaced the first init command with, and let's do it real quick. Where's the RLTK builder? RLTK builder, there we are. We're using it. We do the simple 8050 with title. We build it. We get it back. Context dot with post scale. Oh, that's super easy. True. Can't borrow it as mutable. Oh, we need to make it mutable. And that's it. If you choose to do this, the game looks a bit like the classic Caves of God, and that is a great game. Oh, it totally does. That's a great look. Still having a little hard time reading the text there. Might want to, I don't know if it's just on my end. Even when I looked at OBS, it was still a little hard to read, but I'll worry about that later. It's fine. It's all stylistic at that point. Stylistic, like we can change colors anytime we want. I'm here for the functionality right now. And getting into the algorithms and stuff. You know, as I keep mentioning, we're getting there. We're gonna have to go through quite a few sections, but we get a binary space partitioning later on. BSP right here. Cellular automata maps, Drunkard's Walk maps, mazes, labyrinths, like diffusion, limited aggregation maps. Voronoi hive maps, those look pretty cool. So we got all kinds of crazy like algorithm stuff we're gonna get to. That's what I'm here for the most. We're building like towns with, you know, living bystanders and stuff. Like, yeah, I'm really excited about all this. So that's what we're pushing for. I didn't know I could even do that. Oh no. Oh no. Hang on, I got the thing for it.
Oh no.
Alrighty. Wrap up. Now that we have a GUI, it's starting to look pretty good. Yeah, that's why I'm doing this, even though I just did another one that's built. What we're building here initially is almost the same thing. This one's styled differently, and it's using a different toolkit and everything, but it's using the one that they wrote themselves. This is a little, even like what we're doing here is a little more low level, and in my opinion, because of that, it's a little more interesting. Using the ECS, the Entity Component System, to handle everything. We kind of had a little pseudo ECS in the last tutorial, but this one is again like a proper one. It's much more in depth. So already, like I feel like there's a lot to be gained from this, but that's what I'm so excited. I mean, we go down here and like look at the town, and it just straight up looks like Dwarf Fortress by the time we start doing the town stuff. Like, it looks like we're just hanging out in a Dwarf Fortress city. I think we'll do, yeah, look at this, where you're walking around and stuff. Like, that's crazy. Like, I'm excited to get to all this stuff. It's like gonna be way, way, way down the line. We got dudes talking, like drunk people talking about booze and asking for copper and stuff and asking why you went into someone's house. Like, dude, I love that. So yeah, it does go way more in depth. This is a big beefy tutorial though. So yeah, we've done the user interface. We did dealing damage and user interface. So next up is going to be items and inventory. We're getting to the ranged stuff. Items and inventory looks like it's going to be pretty long. Ranged is going to be pretty long. I'll try to do both on Wednesday, but this might take about 3 hours just based on the scroll bar size of dealing damage and the scroll bar size of items and inventory. This is probably going to take about 3 hours. So I might just do this one next time. You know, I don't want to like just try to rush out and cram stuff out. I want to, you know, really try to soak it up and like learn and take my time with it, you know. I don't want to just like, if I want to just cram it out, I'd literally just copy paste the code and just be done, right? Like, I would already be done with this damn thing. I'm not saying that in a negative way to it, but like if I didn't care about it, that's what I'd be doing, right? You got to take your time. You got to like absorb the information. Alrighty. Let me catch back up on a couple things here. So, yeah, I saw Ice earlier saying usually prefer not to use OOP. Omnivore says, I do like C, not a hater, I just live with OOP. Or no, Jive. You'll agree a great effort has been made to enforce it. Yep, that's sold the military and rocket noises. Yeah, I mean, there was Ada. I don't know that much about Ada, but I think Ada was doing that back in the, was it from the 80s? Ada's pretty old. I know Ada was like the first big military one. It says imperative, so maybe it's not object-oriented. We have paradigms here. Okay, it can do object-oriented, yeah. I don't know, again, I don't know that much about Ada, except it's used a lot in defense. A lot of old defense, and from my understanding, a lot of Ada is getting replaced these days. I know people that are replacing Ada with like Java and stuff right now. They're not having a fun time with it. Apparently Ada has some really cool features and stuff, but it's just whatever. Your dad learned and worked in Java for supply systems because it got sold to them. And you saw a giant subway train at a... Wait, what are we talking about? What's happening? I'm confused. What's happening? Alrighty. Wait for a response on that. Well, I guess I just wrap up here. So, pretty good progress today. Getting the actual combat in, that's probably the most difficult aspect, as was already mentioned. Items and stuff are going to be a little bit time consuming. Range scrolls and targeting, those are pretty cool. Going to be also time consuming. But I'm interested, like, we can already see here we have components like a ranged component and inflict damage component. So there's some cool stuff going on there. I'm interested to see how this kind of all comes together with the ECS, because this is being done, again, a lot differently than the way we did it on the other tutorial. And again, to me, it's in a much more interesting and like generic way that's more extensible. You know what's funny is I'm scrolling down, and then right after I say that, so now we need to make the effect code generic. Great timing. So we're doing all the same kind of scrolls as we did before. See confusion there. We did confusion in the other tutorial. We did like fireball. We did lightning, right? And I think we did we do another scroll? I don't remember anymore. So we're doing like the same kind of scrolls. And no, I'm wrapping up right now. I'm literally ending. But yeah, have a good one, all right? Take it easy. I will catch you later. So we're going to be doing that maybe next time. Saving and loading should be pretty quick. Nope. Oh, because we haven't done a main menu and stuff. So yeah, we're going to have to delve into the main menu and all that. Serializing and deserializing the state should be fun. Skip serializing, skip deserializing. Oh. That's cool. I never even knew that was a Serday feature. That's actually interesting. If you can rederive something, you could save on putting it from your save file instead of serializing. I like that. Not sure why we don't do it unblocked. I don't know, I'm jumping multiple steps ahead here, but just skimming. Just skimming. It's fun to check these things out, right? Alrighty, cool. Well, that's a couple times from now. And as I said, next time we'll go into the items in inventory and maybe range scrolls and targeting. Depends on how long this one takes. If this one ends up being more... it looks like there's a lot of code, so it'll probably take a while. Okay. Yeah, we may just end up doing this next time. So thank you to anyone who showed up today. I really appreciate it. As I always say, I appreciate any kind of feedback or anything on this, but I know when you're going over like a pre-written tutorial, it's difficult to kind of like, it's not my code. You know, at that point, it's like if there's a correction or criticism or something, go to the author, not me on that. But sometimes I interject with my own little changes in the code or something. So definitely any feedback on that is welcome. But I always appreciate feedback on maybe like how I structure this, or if you know, you think I could do something better or whatever. I would definitely appreciate that, because I want to make these videos as good as possible. As I always say, different people learn differently. So if you throw a big wall of text tutorial at somebody like this, some people may not really be able to learn effectively from that. They may need the video, they may need some visuals along with it, like you're getting with seeing me type the code and everything. And you know, maybe me trying to explain and delve into how some of these functions work. Hopefully that helps people out in some way. That's the objective there. And the other objective is that I'm still doing this for myself. I'd be doing this anyway if I weren't streaming it. So it's just a fun way to you know, we get a little bit of interaction here in the chat. And it's just, you know, another... I'm going to be doing it anyway, so why not stream it? You know, make something out of it where other people might benefit, right? So again, provide any feedback or whatever if you got it. Do all the fun follows here on Twitch and YouTube. Like button on YouTube, subscribe, notification bell, all that fun stuff, right? I do read comments. Like I said, you can provide your feedback there as well. So I don't think I have anything else to say. Been a good session today. Been a good time chatting with you, Ice and Omnivore. So until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
You must continue your mission.